senso, loro hanno la cartella qua e c'è tutto qua dentro.
Perfetto.
Lasciamo questa aperta, no? Quando non c'è il tappo e
Mm-mm.
uno sa circa.
Certo, certo.
Se vuoi mettere la tua, puoi mettere la tua. Cercarla per me può diventare pure complicato. Io sopra
Sì, sì, sì,
ho,
certo.
ho tanti altri pensieri, audio, video, immagini da mandare.
Quindi possiamo mettere questo,
Queste
perché
cose.
così c'è anche il programma.
Sì,
Ci ho
vabbè, ma io
messo.
tanto c'ho il tappo mio, sto mandando il
Perfetto.
tappo per il momento.
Senti, invece come puntatore non ce l'abbiamo.
Non l'ho scelto, te lo posso scegliere.
Eh sì,
Te
magari
lo vado a
se
prendere.
può servire.
Hanno imboscata da una parte. Vediamo se ci sono le batterie. C'è.
Ok, c'è il laser pure?
Sì, il centrale.
Questo qua?
È lui.
No, aspetta,
No,
forse è
lo
questo,
vedo, lo
questo.
vedo.
Questo,
No,
questo.
ma lo vedo io, non
Sì, sì,
vedo
sì, è
mai.
questo qua. Non si vede, non ce la fa. Secondo me è troppo.
Non è troppo luminoso, però non arriva mai imboccato.
C'è, no, qua c'è. È un po' scarsino. Ma
Si perde sul...
vediamo se più. Io ce n'ho pure uno. Questo qua, quello di Logitech, ma.
Io ne tengo uno in Wish che è il migliore che ho. Prova, prova, sei prova.
No, su questo schermo non si.
No, su questo schermo è difficile vedere tutto. Irio, alza un po' il volume, questo qua è la... Prova, prova, sì, prova.
Sì, vediamo, andiamo a vedere. Please take a seat. C'è il coso pure, eh? Okay, so let's start. Ladies and gentlemen, dear colleagues, welcome to this second Spoke workshop on Green Aware AI. Well, you know that this is a big challenge to design an artificial intelligence that is aware of the green dimension. And I'm very proud that we are here. We are registered more than 100 people. And we bring together in this event not only researchers from universities, but also researchers from companies. And we have the opportunity to foster new collaborations. We designed an event in the afternoon where companies will have the opportunity to present some innovative projects. And I encourage all of us to join this poster session and to identify new possible ideas for collaborations and to make advances on these innovative projects and to possibly design new projects and share ideas with them. Before we start, I want to thank everyone who helped make this event happen. A special thank you goes to Antonella Pellegrino, Andrea Attanasio, and Simone Carnevale for what they make for this event. And now we will shortly present our spoke for those that are not aware of our project and for people that are connected from the web, because we are streaming on YouTube this event. So you know that this project is the big project on AI in Italy. It is funded by the Next Generation EU, and we have a critical mass of 350 people. You see the map. We are distributed in Italy, but we have many more universities, and I'm very happy that we have here other 12 universities that joined us in this project. So the real map is much more rich, and for next time I promise that I will update. Sorry for that. It's an old one. The project also have some partners from the very start of the project, because the ministry wanted that some companies, some big companies in this case, should participate in this project from the start, from the design. But we have now in our ecosystem further companies that I'll present next. So these are the foundational aspects that we will face in the project. So environmental and social impact, human interaction, contextual perception, self-awareness and adaptivity, social interaction, and security and trust awareness. All of these aspects are individual challenges that are faced in all the spokes in the project. There are some transversal projects that are designed to foster collaborations among the different universities. And our special focus is about green AI and AI for green. We know that the new system are very eager of energy, and it is quite difficult for not just for people, but for countries that are not very rich to afford for the most powerful systems. So it's very important to design systems that are good not just from the performance point of view, but also as far as the sustainability aspects is concerned. And but our goal is even more general and more ambitious, because we are looking at the green dimension, so a dimension of AI that cares about the sustainability, not just from the environment point of view, but also from the point of view of social inclusion, of gender bias, all the different aspects that are important as far as the sustainability development goals are concerned. I'm referring to the Agenda 2030 goals. So our spoke is composed by the so-called critical mass. This is the term used in the project. We are 33 persons from Unical, CNR, and GSSI, with Michele Flammini, that is now affiliated with Unical for the project. And we have 18 new researchers, 15 from Unical and 3 from CNR. We have 3 research fellowships, 2 research grants, and 8 PhDs. So many people involved in the project. We have some leading research groups with many expertise in all of this stuff. And these are the universities that joined us in this project. So I welcome Palermo, Aquila, Sassari, Reggio Calabria, Catanzaro, Chieti Pescara, Salento, Gran Sasso Science Institute, Messina, Salerno, Università Politecnica delle Marche e Università degli Studi di Brescia. So a very nice ecosystem. And these are the companies that joined us. So Revelis, 15 Genium, Dune, Touristic Platform System, Two Smartest, Proton, Ener2Crowd, DigiTwin, Kairos, VT Solutions, TrueSense, and eInformatica. Okay? And so, as I anticipated, we will have a specific moment dedicated to all those projects in the afternoon. And these are the work packages. I will not spend more time about that, because we will have one session dedicated to each of these moments. And now we will have a short summary of our main achievements up to date with Antonella Guzzo, please.
Thank you, Francesco. Okay. Good morning to everyone. As you probably say, the KPI are defined for monitoring the evolution of the project along 6 main objectives, 5 of which are defined at spoke level. So let me present our achievement at month 24, so we can discuss our progress made so far and where our attention is needed to be focused. Let's start with the objective 1. As you can see, we have 12 KPI that is grouped in 3 different actions. And the green color identify which milestone has been already reached. So you can easily see that we perform very well in all KPI, since they have been reached at month 24. But let me focus on our scientific production. Here I'm showing how our papers are distributed along the class rating. You can see that in our spoke, researchers mainly published in Q1 journal, while the conference contribution span in a very different class of rating. But what it is important to mention here is the first result that is the number of the paper published at the 24 month 24, is exceed significantly the target at month 36. And another strong point that I found in my analysis is that target at 36 is already reached by only considering Q1 journal and class 1 paper. This is, in my opinion, a strong results that demonstrate that our productivity is high in terms of quantity, but also in terms of quality. So let me now just discuss how our production span along the 3 dimensions. This is the objective 3, where hub monitoring our effort along human-centered action, robust and trustworthy, and sustainability. You can see that the performance results have the same trend also for this KPI, but we have excellent results in the green dimension. This is most important and in some sense expected, since our SPOC is focused on green and sustainability. Here, I would bring your attention for the KPI regarding the paper published with industrial co-authorship. It is evident that we have a critical point here. We didn't reach the target. We believe that the ongoing collaboration with industrial partner can help in reaching this target as well. And let me conclude by summing up the main results. 50 KPIs, over 55 KPIs have been already reached at month 24. This is a strong results, demonstrating that we are doing very well along over all objectives that are monitored in the, from the hub. But I will stress once again on the critical point. The first is gender balance, since the number of female participation remain below the target. Similarly, the number of young researchers involving in interspoc activity. And the last but not least, we must publish at least 3 papers with industrial co-authorship before month 36, before the end of the project. That's all for my side. I don't know if there are any questions. No? No question.
Any question? No? Thank you, Antonella. So an important point here is to understand what is a magazine for general public. Okay, that's quite unclear at the moment, but it seems that there is some flexibility. So I mean, you can imagine that everyone can publish on something that is not precisely from researchers, but in fact, according to the hub, they are also considering something that is for different scientific areas. So something that is somehow not directly focused on our specific area. Okay, so in a sense, multidisciplinary. Okay, it's could be accepted for this KPI. Of course, a very general venue would be better. And let us conclude with a further note. We are going to get the hardware that we acquired with the project, and we are going to get this very nice machinery made with 2 nodes iGPU, with equipped with each one with 8 H200 NVIDIA GPUs. Okay, so it's a very, very nice machine that we can use all of us in the project for nice possible applications. And let me conclude with the next appointment. So save the date. We have another workshop on green aware AI at ECAI 2025 from October 25th. So please take notes. We are the organizers of this workshop, and it will be a nice opportunity to stay together even at ECAI. So I hope you all enjoy both days, and I look forward to the conversations ahead. Let's start immediately with the next session. Thank you for being here. So I invite now GP, and possibly to be faster, also Luca and yes. Also, Luca and Giuseppe Mazzotto can also join us here so that we can be faster. And you find here the presentation. No, other one. Okay, so.
Oh, yes, thank you. Okay, thank you. I'm B.Andreatta, and I'm one of the 2 principal investigators of the first work package, which is titled Knowledge Representation and Frameworks for Green Aware AI. Well, the topic of the work package is basically investigating the relationship between knowledge representation and reasoning, which is basically the big topic which the work group involved in the work package works since several decades now. I will not make the shopping list of the tasks, but they can be roughly categorized in 3 groups. Today we will have a talk taken from task 9.1.4, which is about computational issues for cheap and efficient reasoning in ASP, and Giuseppe, that I don't see, he escaped, I think. Ah, okay, you are here. Giuseppe will speak for us, and this is the very first time we have the opportunity to interact in an official event with all the cascade calls for academic entities. So we will have, not in the schedule order, we will have a talk by Simona Rommo from University of Palermo, which will talk about her project called Magna, that is basically under the umbrella of task 916. Then we will have a talk by Stefania Costantini of University of Aquila and Luca Pulina, which will be the first in schedule order, talking about his sub-project SCET Monitor. Under the doesn't work. Okay. Okay, under the umbrella of this work package, we will soon start relationships with 3 of the small and medium enterprises that were awarded the funding for the apposite call, and their project more or less range over the idea of using AI in climate research. We have a project on agrivoltaic systems, and also an interesting proposal for optimizing training of machine learning models. And this is it for the introduction. I leave the floor to Luca. Find yours.
Thank you. Thank you for the introduction. Good morning, everybody. I am Luca Pulina from University of Sassari. Thank you. First of all, I apologize because my slides are in Italian. There was a misunderstanding about that, but I'll try to explain them in detail. So now I'm here to tell you about our project introduced by EGB, SCET Monitor Project, that is the acronym of Smart Knowledge Driven Environmental and Territorial Monitoring. The idea is to realize an experimental system about intelligent monitoring that could be used for decision support per a sustainable management and governance of the territory. This kind of system what integrates some environmental sensors and some behavioral sensors for several things related to anthropic load of territories, a digital twin of the territory, a symbolic AI module based on associated programming in order to model and simulate some policies. I will tell you about some details in the next slides. And a module for predictive AI in order to highlight trends about related data. The target of this project is to support local governances with a platform in order to see and evaluate the application of green-related policies. Why this kind of system? One can think about, about intelligent monitor system today in 2025 with predictive AI, with sensor, with IoT. There are a lot of this kind of systems. The point is that in general, this kind of systems are a very general scales. And this cannot allow to model policies that can be applied in specific places in which these policies can be more effective and then can have more impact. In general, in the last years, also the United Europe has, let me say, changed this kind of way of thinking in the sense that they are passed from a top-down approach that is centralized to a bottom-up approach for this kind of policies, including the ones related to the environmental transition. Reasoning on bottom-up approaches and on approaches that are called tailor-made, in the sense that to be effective, they should be tailored in the particular environment and particular reality. This change of visions about the application of policies let emerge the necessity to responsabilize local actors, so local governments, to manage this kind of policies. And in order to do this in an effective way, the idea was to experiment this kind of system supported by AI in a very tight relations with local authorities, in order to design this kind of policies in a proper way. So the system that we are designed is structured at a very like level in this way. We have an environment that we are using as a test with several sensors that are connected with a common interface. Common interface that fulfill a urban data platform emulator because of we have also another problem, not only the, let me say, green transition, but also the digital transition. So most part, as you know, of local municipalities have not a urban data platform in the proper sense. So we are emulating these and using these also in several contexts that I will mention at the end of the talk. These data contained in this urban data platform will populate the modeling of the particular environments that we are considering for the application of these policies, modeled as a digital twin, which is connected a module related to AI, in particular symbolic AI. All this data will be presented, aggregated, and elaborated, both for reporting and both for reporting suggestions as a decision support system to a dashboard that will be that could be well suited by local authorities. So in our case, in our specific case, this is a pilot project, this is an experimental environment. We are considering a place in the Alghero city, especially a beach that is very close to the urban center, as you can see here from the picture. And this is our test environment, is Spiaggia di Maria Pia. And this is an interesting environment because on the one hand, you have a set of environmental issues related to dunes, to some problems, some touristic pressure to this beach. And on the other hand, is very close, as you can see from the map, to the city center and with a lot of traffic and a lot of other problematics that are more strictly correlated to a touristic city as Alghero. To set up the monitoring system on this place, we have designed a setup that we are currently implementing after a bureaucratic after a lot of bureaucratic issues, believe me, in order to install a lot of sensors that are able to monitor environmental parameters and some other parameters related to how the place is crowded, especially in touristic periods and so on. This kind of sensors are heterogeneous, so we implemented an interface in order to assess this data in a uniform way. Nothing of complicated. Next step is to populate the urban data platform with this data, and this kind of data, this kind of module is the one that in which all data are centralized, not only the ones related to the sensors coming from the beach, but also several other sets of data related to other activities that can be related, that can be involved in this analysis. I think the waste management plans or traffic data and similar stuff. In particular, this kind of data would be integrated with external sources from this point of view. In order to focus to specific areas to monitor and to compute, let me say, suggestions for policies to apply, especially focused on the green aspect, we need to model all the selected area and this is the role of the digital twin module, in the sense that this kind of modeling will be implemented, is partially implemented. I will say something about that at the end of the presentation, considering not only the data coming from the urban data platform, but also other kind of data related to the structure and access, the environmental state, the policies related to the management of this place, and so on. The next module is the one related to the AI reasoning, and it is the module that do the job. Let me say. The idea here is that encoding the model related to the digital twin on the one hand, populated with data coming from the UDP and mapping this with the possible policies associated to the management of this place, an AI reasoning module can give some suggestions about strategies to apply to a particular places in order to preserve them. Just an example, also this is the more complicated module, let me say, not only because there is the technical part related to research, but also because there is the interaction with all the local stakeholders, municipality, category associations, citizens associations, because of we need to know this kind of policies in order to try to model them. Okay, so we are now doing this job in a series of co-design sessions with these stakeholders. This is just an example. Suppose that in this summer, this system revealed a crowd environment, a CO2 that is quite high in the rush hours, and some levels related to PM that can let's see as a warning in this sense. And so this kind of consideration can, let me say, let's think us about which policies activate for the next summer in this sense. So we are working using answer set programming. The point was to model both the environment, data coming from the UDP, and the digital twin of the particular places to map them with policies. So we have some environmental facts, some thresholds, some critical conditions modeled on the one hand, and these are connected with some policies that can be activated, as you can see in this part of the slide and explained in the table below. So the point is that connected these elements together with, when the system will be completed, with other elements connected surrounding areas, this can be a tool that can support local authorities in order to trying to apply some policies related to the environmental management. The last module of our system is a dashboard. We are using open source tools like Grafana to implement them, that could be used not only for monitoring in real time all the values, but also as a front end to manage the suggestions coming from the systems. Okay. Now we are a month 12 of the project. This is the current advancement of this. We complete the definition of requirements and the case study and the design of the hardware and software architecture. Now are working about on the design of the digital twin of the territorial management model, as I told you just a couple of slides ago, and we are modeling all the techniques in order to let work the AI reasoning module. Another interesting aspect, in my opinion, is the connection of this project with other projects. In particular, other PNR founded ecosystems around of Italy. The first one is the Sardinian ecosystem, EINS, in particular spoke to tourism and cultural heritage, because of we are considering the extension of the data computed in our environment in Scat Monitor, also with the reviews that can be collected for a sentiment analysis, for instance, in the sense that some criticalities from an environmental point of view can come not only by data taken by the sensors, but also by opinion, for instance, of tourists that can visit the place and so on. Another interesting connection with the Cascade Call project Seaweed from the ecosystem Arise of the region of Liguria. We are working on this implementing a similar system, but the target is are the citizens, in particular the fragile one, in order to implement some suggestions about the, let me say, the usage of a place in the city mapped to their problematics. And another couple of projects in which we can find connection on these are two founded by Sardinia region, Inter and T3, in which we are studying the application of this system for the environmental policy management applied in internal areas of Sardinia. So thank you very much for your attention. We are discussing not only about some computer science thematics, but also by economic and geographic ones. These are my two colleagues that are helping me in this, and so thank you. That's all.
Thank you, Luca. Questions?
Questions?
No, I have one, so I'm the chair. I have to make a question. You know.
It's mandatory for you.
One thing, is there some feature or aspect of ASP in general that you would enjoy, but you couldn't have with the current systems?
Now we are in the modeling stage, so the point is that at the current state we are working, we are trying to working with preferences, for instance, and we are currently modeling with aspects with weights and stratification. I don't know if this is the ideal one to do that. We have to test and see what are the results.
Okay, so you don't miss nothing particular. ASP is perfect.
In this case, yes, because of three main aspects. Let me say. Sorry, maybe I not stressed this. The first one is that ASP, difference with other methodologies for knowledge representation, can allow us to easily, let me say, encode more policies that can be in alternative, okay, as you can see from this rule. The second one is that is enough, let me say, high level, the encoding, in order to have an not easier but less difficult job to model, to use the same kind of model in other contexts. These are the, let me say, main feature because of we choose this kind of technology.
Okay.
I don't know if I answered to your question.
Yes.
It's more difficult than this.
Maybe we can talk later also. Thank to the speaker again.
Thank you.
And next speaker is Giuseppe Mazzotta, which will talk about optimizing ASP evaluation for a sustainable declarative AI.
Okay. So, hello to everyone. I'm Giuseppe Mazzotta, and today I will talk about the optimization of ASP evaluation for sustainable declarative AI. And in this presentation, I will present some of the work that we have accomplished together with Carmine Dodaro and Francesco Ricca at University of Calabria. So, answer set programming is a very well-known declarative AI formalism for knowledge representation and reasoning that found extensive applications in different AI fields, such as natural language processing and understanding, planning, scheduling, among many others. The success of ASP is due to the combination of two factors: an highly expressive language that allows to model hard combinatorial problems, and the availability of efficient system that implements the stable model semantics of ASP. How answer set or stable models of an ASP program is computed. Basically, ASP solvers employs two-stage approaches, where in the first step, the program is first grounded. So basically, a grounder module computes the propositional counterpart of an input program, and then at solving stage, there is a solver module that performs a propositional search for stable model. Now let's see how this works in practice. So here I have reported a very simple a very common problem, that is the graph coloring one. And basically we can model such a problem with these few rules. Basically we are guessing an assignment of color to nodes of an input graph, and then we would like that each node is colored with exactly one color, and not two adjacent nodes are colored with the same color. Then we can encode the different problem instances that in our case are input graphs, for example, by specifying a set of input facts among the predicates node and edges. And during the grounding stage, here we produce all these rules. So basically we are substituting variables with all the constants that appear in the program itself. Then the solver module takes as input this ground program and computes the solution to the specific problem that we have encoded in our problem instances, that in our case are basically valid graph colorization. So what about larger instances? We have seen that during the grounding, the size of the program start to increase very rapidly, and it depends on how many variables we have, how many rules, how many constants. So it has been studied that ground and solve approach suffers of an intrinsic limitation known as a grounding bottleneck, where the program generated by the grounder in many cases does not fit in memory, and so the model computation process cannot start at all. In recent years, many efforts have been dedicated in order to mitigate the effect of this problem, and among such techniques, compilation-based ASP solving revealed to be a very effective solution. What's the idea about compilation-based ASP solving? So basically, it's based on this question: do we really need to ground everything? And in the first approaches that have been proposed in this field, we can see that there is an approach that skips the grounding of constraints by compiling those constraints into ad hoc procedure that simulates the presence of ground constraints during the solving. Now, for example, if we come back to the previous example, we do not materialize the grounding of the constraints that we have seen previously, and we convert non-ground constraints into procedure like this. So basically, an example of procedure could be one of this form. As soon as we have an edge that is true in our interpretation, and there is an assignment of color C to the node X, then we should propagate into the solver that the node Y that is adjacent to X cannot be colored with the same color, and so on and so forth. Can we do more than this? And here our main accomplishment, that is the ProASP system. So basically here we developed a compilation-based ASP solver where our objective is to compile an entire ASP programs into an ad hoc solver. How this solver will behave? So basically, we decide which subset of the rules of the input program we would like to ground, and which rule we want to simulate during the solving phase, and we obtain this ad hoc solver that is called here PySolver, that is able to solve any instances of the compiled problem. So now let's see how this works in practice. So in At compilation stage, basically, we start from a non-ground program. We select the rule that we want to ground and what we want to simulate, and there is a first rewriter module that basically computes two programs, the generator program and the propagator one. The propagator one is obtained by applying a series of rewriting steps that generates a set of rules such that by converting such rule into dedicated procedure, we can simulate all the inferences that comes from the rules that we have selected as to be simulated, let's say. Instead, the generator program, by gen here, contains the rule that defines the domain of each predicate of the propagator program and contains also those rules that has to be grounded. So now there is this compilation stage here. The two programs are compiled into two different modules that are the generator and the propagator. The compilation of the generator program will originate a set of bottom-up evaluation procedure that in some cases materializes only the domain of some predicates, and in other cases materialize the ground rules that we want to take care of during the solving, while all the rules in the propagator program are compiled into rule-specific propagators that simulates the inferences. Now let's see how the PySolver will look like. So basically we have three modules in the resulting solver. The generator and the propagator are the module that we have seen just in the previous slide, so the output of the compilation stage. And these two modules are integrated together with a SAT solver here that performs the search for stable model. So this is how the compiled solver will look like, will compute stable models. So basically, starting from a program instance F, the generator module computes the domain of all the predicates of the program and generates also the ground rules that we have compiled before. The grounded rules are then transformed into clauses, since we are using a SAT solver here, and this can be achieved by applying standard techniques like the Clark's completion. And then the generated clauses together with the atoms obtained by the generator become propositional variables, and the CDCL of the SAT solver can start. During the CDCL, now the SAT solver can compute propagation in two different ways. So from one end, the clauses encoding grounded rules will simulate the inferences that comes from ground rules, while it can interact with the propagator module that is able to compute the inferences as we have seen in the previous example, and in this way, the propagation will cover the inferences of all the rules of the program. If some conflict happen during the CDCL, so our interpretation become inconsistent, then the SAT solver is able to analyze the conflict by both using the solver clauses that represents the ground rules, but also asking the propagator to reconstruct the reason why some literal have been inferred. Since we have, in the propagator, we have no rules materialized, so it has to simulate this during the solving. In order to evaluate the impact of our approach, we performed an empirical evaluation where we compared our system with Klingo. That is the actual state-of-the-art ground and solve system, and we compared this with 8 different versions of the ProAsp system. As I said before, we could have for one single program an exponential number of possible solvers, and since it is not feasible in practice, we decided to consider all these versions. So the version in which we decide to ground all the rules, the version in which we decided to simulate, so to compile all the rules, and 6 different blending strategies of these two approaches, where, for example, we would like to ground only a set of rules characterized by their syntactic features, for example, rules that contains aggregates, normal rules, constraints, and every combination of these 3. And we considered in our evaluation 14 benchmarks for a total number of 2,366 instances taken from ASP competition and previous comparison. Here they obtained the result. As you can imagine, compile everything, since skip entirely the grounding phase allows to save much more memory. In fact, here, as you can see, the green line is much more lower than the other one, while ground all revealed to be very effective when the grounding is feasible. In fact, it takes a smaller execution time. In general, if we compute the virtual best solver, so the solver obtained with the best split for every benchmark, we obtain the result in red. As you can see here, the hybrid approach combines the advantages of the two. It is the fastest one and also the one that consumes less memory. Now, if you look at the environmental sustainability impact that our approach has, we can see that, for example, in our experiments, we used a specific processor of one of our computers in our labs. And if we compared the total energy consumption that we obtain by running the best version of ProAsp for every benchmark and Klingo, you can see here there is a nice, a significant reduction of the total kilowatt hour that has been consumed, 16% for ground intensive benchmark and 60% for the grounding feasible one. So this amounts to a reduction of the emission of CO2 for on average of 130 or 160 kilograms. And in general, another important aspect is that by reducing the amount of computational resources, we can use commodity hardware to evaluate ASP programs, and this, of course, will reduce again the impact on environmental sustainability. So, to conclude, the availability of an efficient system made ASP a valid solution in different AI fields. Standard techniques are affected by grounding bottleneck that basically, where ground and solve approaches basically requires high computational resources also for evaluate just simple, just a few rules. And this is has a dramatic impact both from the application side, so it limits the applicability of ASP, but also on environmental sustainability, because we need much more powerful machines. Compilation-based approaches revealed to be very effective. They provide an easy and flexible way to customize the evaluation of ASP programs, and it allows to find the best evaluation strategies for your ASP program. Both the solvers produced as a very lightweight evaluation process that we have seen as also a positive impact on the environmental sustainability. As future work, we plan to enhance such compilation-based approaches by still optimizing our propagation phase and try to postpone as much computation as possible at the end of the process, since this will, of course, save resources at first stage. And as another key point of our future work is expand ProAsp horizons in such a way that we can target much more complex language fragment, and allows also the usage of optimization statements that are used very often and are really powerful. So that's it. Thank you for your attention.
Thank you, Giuseppe. Questions from the audience? Very shy audience. Luigi.
My question is the following. Is your technique applicable to any kind of ASP-based system, or it is tailored on a specific one?
No, in general, let's say the techniques are very at a very high level. So, in general, when you want to apply this technique on a different system, you need to have an external, let's say, interface for your system where you can plug such propagator procedure that are generated in the compilation stage. Of course, we have built a new ASP system that relies on a SAT solver, but from a theoretical point of view, this can be applied to whatever solver that allows the possibility to inject this propagator procedure during the solving.
It's interesting because this can be the basis to multiplicate the positive impact on the energy saving side.
Yeah, sure, of course. You're welcome.
Okay, thank you, Giuseppe. So, next speaker is online, and is Stefania Costantini, that should talk about patient management via ESP and LLMs. And is there somebody up there that can help us?
Because I am not allowed
Stefania?
to share the screen.
C'è Simone.
Tutte e due.
Yes,
Stefania is trying to talk, but
no microphone.
no microphone, I guess.
No, the problem is not the microphone. The problem is that I can't share my screen.
Possiamo leggerla da qua.
Can you hear me first of all?
Ce l'abbiamo. Sì, ma...
Okay, do you see my screen? Can you hear me?
Yes, we can hear you and we see your screen.
Okay, perfect.
Okay.
So I can start. Sorry, I cannot show myself because I am ill in bed, and so it's better not showing. Good morning, everyone. I'm very sorry not to be there with you, but I can't. And so I will talk about this first part of the Enable project. The Enable project
Stefania, can you go in presentation mode?
In presentation mode, okay.
Should be either F12, F12 oppure penultimi icona a destra.
Okay, so doesn't work, let's try.
Penultima icona a destra.
Penultima icona a destra dove? Qua?
Ci sei,
Okay. Yes. So this the first part of the Enable project, the aim of the Enable project is to create a livable urban environment, and the green aspect is to contemporate the objectives of the single citizens and group of citizens, and the objective of the entire city, okay, concerning the use of every resource, from electricity to water to whatever services are granted to the citizens. Now I cannot shift my slide. Sorry. Can you still see my slides?
Yes.
Okay, no, because if they are here, I cannot. So, one point on which we concentrated is the assistance to patients, which is healthcare. Healthcare is very important nowadays in the urban environment, especially because the number of older adults will very soon be higher than the number of other people, and human caregivers are scarce and costly. Not everyone can afford them all the time, and the resources of hospitals and medical centers are also scarce and costly. And so artificial intelligence, and in particular in this picture AI agents, can improve the quality of life of patients by offering medical support and assistance, and can support the urban environment by helping to optimize the use of resources. Another use of AI agent might be that of assisting neurodivergent persons, which means persons with special needs of many kinds, improving their interaction with the world. And so the aim of the Enable project is to design AI agents to support people on the one hand, and optimize the use of resources on the other hand, to create a green holistic city. Now first, the first idea that people have for AI agents is to use large language models for user interface. But do large language models understand and communicate? Okay. The answer is no, because communication is not just about transmitting words, but transmitting intention, serving communication objectives. For instance, now I am trying to illustrate to you the work done and convince you that this work is good. Okay. So there are communication objectives, and the aim is to create a shared understanding between parties. Understanding means, interpreting the message in the context in which it is expressed. So it is clear that large language models do not communicate, also because they do not have a body. Okay, and so they do not have clearly a body language. They can hardly consider the receiver's culture and experience that influence communication. You give to the LLM a question and you receive an answer which is context independent. Okay, and last but not least, a good communication is also a good listener, able to grasp the intention beyond the words. And so, yes, we can use large language models for user interaction, but these large language models must be tuned to on the user communication preferences. The user is a patient. Okay, so how much does she want to know? Or how much she prefers to be communicated to the caregiver? How often she prefers to be told to? Okay, the frequency of communication that she prefers. Okay. How can communication help the patient and not raise the levels of anxiety and so on? And so we should tune the large language models on the one hand by adding elements from the theory of mind. The theory of mind is the ability that we developed when children to understand the wishes, the intentions, the feelings of others, and adding the single patient's communication preferences. Then, to implement these AI agents to aid the patients, we used our language DALL-E, which is an agent-oriented programming language developed in our research group. But we have to compare with the nowadays fashion of LLM-based agents. How do LLM-based agents work? They gather observations from the world, put the observation in memory. They basically, now let alone this few short prompt, they basically ask the LLM about which is the action to perform, and after a very simple process of thought, they memorize this action in memory to be able to repeat it the next times. But for us, the structure of intelligent agent is much less simple, in the sense that the agent has a model of the world, okay, has a prior model about the world, has goals and utility, as the list of possible actions that the agent is able to make, clearly interacts with the environment, but in our view, in the view of the entire community on agents and multi-agent systems, decides the agent the actions to perform, not only based on simple reactivity, but by means of reasoning and decision making, by means of complex knowledge representation and automated reasoning techniques. Still, LLMs can be useful. We are integrating LLMs in our daily agents to the aim of the Enable project. How? Because it is often been said that agents based on computational logic are brittle, in the sense that they are designed for a particular situation and they cannot adapt to new situations even similar. Okay, so what do? We use LLMs, okay, to gather information about the particular context in which the agent is situated, if this context is new to the agent. So we gather new facts, we gather new actions that can possibly be made in the context, and so we, for instance, imagine that you have an agent that was born in Calabria and is aware about food, medical centers, places in Cosenza. Okay. Now our agent will, and also which animals are dangerous in Cosenza, which is known basically, but this agent is now transferred to Alaska. Okay. It can obtain by means in a city of Alaska, and it can obtain by means of the LLM, which are the animals, the food, the places, and so on, and so become able to function in an environment very different from its own. Thus avoiding the brittleness these agents were accused of. Then, what is the role of ASP? Our daily agent uses ASP a lot. Okay, and in particular, in the context of the project, we wanted to optimize. You have the patients that have to go and see a doctor or undergo a visit at the hospital and so on. We would like, in the spirit of the project, to dispatch the patients, okay, scheduling the patients, while optimizing the use of the healthcare resources. This scheduling is novel because we don't only take into account the usual things like clinical urgency, the illness of the patient and so on, but also patient preferences, budget constraints for both the patients and the hospital. Okay, how much can the patient spend in terms of time and money for the visits? Which are the budget of the hospital and what can it offer? And then we take into account accessibility for disabled or neurodivergent patients. For instance, it is hardly possible that a person with a wheelchair or an autistic child, okay, climb on a crowded bus. And the ASP model components are what you can imagine. I will not show the code. facts, constraints, objectives, and as additional information we added users and doctors personas. Blueprint personas were a concept that was introduced by the European community and that we further expanded and refined during the Enable project. It is useful for improving healthcare delivery, for personalizing digital solutions while engaging multiple stakeholders. Blueprint personas basically are standard data-driven profiles, okay, that reflect the medical, social, and lifestyle factors of the patient. Okay, and so the patients, and in our case, we introduced the blueprint personas also from the doctors in order to send the patient to the right doctor. For instance, an autistic person will be sent to a doctor who has experience in treating this kind of patients. So the healthcare system can adjust to individual needs, supporting a user-centered and patient-specific approach. Okay. We are writing a paper for ICLP about this ASP code, including blueprint personas, and what we see as, so to say, a demonstration of efficiency is the appointment optimization from both sides, especially from disabled patients. Sensory environment preferences in the sense that we compute via ISP the route that these patients should take and the transportation means that they should take, because as I told you, maybe people with wheelchair couldn't take, maybe the hospital should provide a van, okay? Multi-patient prioritization across limited slots and compromise between objectives and preferences of the patients and of the healthcare system. What's next? We are working together with the University of Messina about resource exchange, when it is possible, among medical centers to dynamically better respond to patients' needs and better optimize resource usage. And the conclusion, we want basically, we want to do the things that I said before, but we care much about the adherence to human values and the respect for human rights that are often lacking in the present, in the nowadays care system that provides a lot of aid to people, but also sometimes considers people as objects. Thank you. Questions?
Thank you, Stefania. Questions from the audience. I will repeat for Stefania that maybe. No questions from the audience, so I have my question, Stefania.
Yeah.
So, did you consider some particular treatment of the possible hallucinations that the LLM could produce and then store in memory in your architecture? Some filtering?
Yes, we did. To this aim, I just supervised a master thesis about hallucinations, and there is much work to do on that. Okay, so you cannot just rely on LMS on this, but it seems that hallucinations can be coped with prompt reformulation, possible more explicit reformulation, and possibly in several ways comparing the answer. However, this thesis was quite interesting. Thank you for the question.
Okay, thank you very much, Stefania, again. And last talk of this session is about study of relevant interactions for sustainable development support, and Simona Rombo will update us on her Magna project.
Yes. Okay. Can you see my screen?
Yes, we can.
Yes, we can.
Okay. Okay. So, good morning, everybody. And okay. Good morning, everybody, and thank you very much to Professor Yanni for his nice introduction. Thank you very much to the organizers too. So, today I will talk about some results that we have obtained in the context of Malta, that is a cascade call of the project fair on models and algorithms relying on knowledge graphs for sustainable development goals, monitoring and accomplishment. And this is the timetable of the project, and as you can see, we are more or less in the middle of it, and we have already finished some specific activities on picture extractions, on which we are also writing a paper. And so now we have started with the second group of activities that are on general problems involving knowledge graphs and sustainability, and in particular with the design and implementation of specific algorithms that use just knowledge graphs for their modeling. But we have also started the analysis of these algorithms and their application to three main application contexts that are in the third group of activities. The first one is micro and macro factors influencing GCSEs. The second one is monitoring of electric and hydric consumption, and the third one is on the connection between stakeholders that are involved in specific sustainability tracking. Well, if we would like just to understand the positioning of these activities with references to the sustainability development goals, we may see that the tasks about how specific factors may influence GCSEs, of course, are in the context of SDG 3, that is good health and well-being, while the monitoring of consumption is naturally related to SDG 12 on responsible consumption and production. Finally, the connection among stakeholders is related to SDG 17, partnerships for the goals. The project benefits of the direct collaboration with the Center of Sustainability and Ecological Transition of University of Palermo, because I am a member of the council of this center, and I also coordinate its data observatory. Well, today I will show some results about the topics related to SDG 3, and another collaborator of the Project Malta will show some results that we are obtaining on SDG 17. So let me just start with the micro and macro factors influencing the GCSEs, and in particular we have started to study some specific molecules that are not so much characterized in the literature, that are long non-coding RNA, and they are known to be involved in the mechanisms of very complex diseases. On the other hand, there are other types of molecules that are microRNA molecules that are much better characterized. So the main idea of our approach is to consider the known, that is the verified associations between microRNAs and diseases that are about 20,000, so a very large set, and try to infer novel associations between long non-coding RNAs and diseases that are still a couple of hundreds. just using these intermediate interactions between long-non-coding RNAs and microRNAs. So the idea is consider the intermediate interactions between these two types of molecules and try to infer novel associations between long-non-coding RNAs that are less characterized and diseases using the association, the known associations between microRNAs that are better characterized and diseases. This is the pipeline of our approach. In particular, we take in input the interactions between microRNAs and long-non-coding RNAs that are stored in public databases, and also the known associations between microRNAs and diseases. At the basis of the approach, there is the construction of a tripartite graph, and the first approach, the first algorithm that we have designed is NGH, that is based on a neighborhood analysis performed on this tripartite graph. Then we have used the tripartite graph also to build a collaborative filter with another algorithm that we have called CF. And then we have also tried to boost NGH by collaborative filtering. We define as neighbors two long-non-coding RNAs that share some microRNA on the tree, on the tripartite graph. And we also define a prediction score between a specific long-non-coding LI and a specific disease DJ. And we have a real value that balance two terms in this prediction score. The first term is representative of how many and to what extent there are microRNAs that are shared between LI and DJ. While the second term is more related to how many microRNAs are shared between the neighbors of LI and the disease DJ. But just because we know that not all the microRNA and long-non-coding RNA interactions have already been discovered, and the same occurs for microRNA disease associations, we can say that we are in a typical context of data incompleteness where collaborative filtering can be successfully applied just to support the prediction process. And for this reason, we consider as a right matrix that we have called relationship matrix, where we have long-non-coding RNAs on the rows and diseases on the columns. And we have defined just two approaches, as I have already said. The first one is CF, where each element var is set equal to 1 if the corresponding long-non-coding and the disease share at least one microRNA and 0 otherwise. While the second approach is characterized by the fact that R is filled just with the normalized version of the prediction score that I have shown before. So this is the main difference between the two approaches. Well, we have validated these three algorithms on a very large set of data. I have shown just a representative result because all the results agree. And in particular, the three algorithms all improve the accuracy with respect to the literature. And in particular, this means that, first First of all, the neighborhood approach is a good way to go, but its boosting with the collaborative filtering is the best choice. We have also published these results recently on BMC bioinformatics, and so this is a first important result for this application context. Now I'd like to leave the room to Ilenia Galluzzo to talk about the connection among stakeholders. So Ilenia, okay.
So good morning to everyone. In this preliminary work, we propose a framework for building a collaborative platform that can support system dynamics experts in identifying new collaboration and innovative solutions. So, what are SDGs? They are Sustainable Development Goal developed by United Nations as part of the construction of 2030 agenda, which include goals that aim to address global and local challenges related to different contexts such as environment, society, and economy. However, implementing these 17 goals can be challenging. An approach of vertical alignment of goals between local, regional, national, and international level of governance for sustainable development need to be adopted. And therefore, a process of designing, implementing, and monitoring strategy at the community level need to be also implemented. In addition to this, it must be emphasized that the interdependence of some SDG may limit the effectiveness of policies aimed at addressing individual issues. This implies the need to consider the set of issues holistically. In detail, the approach proposed in this work aims to improve the localization of the SDG through the creation of collaborative platforms supported by knowledge graph. Knowledge graph can be used for the creation of shared meaning, the understanding of different perspectives, and the promotion of a common vision of the system. The application will be developed to support system dynamics expert. This methodology will be used to facilitate the learning process in the planning and the implementation of policies shared by different stakeholders. Our process generally consists of 4 steps. First, we extract and collect the data. Then we create a working table representing the different sustainable development goals. In the third stage, we build the collaborative platform. Finally, we find the most likely connection between the different stakeholders to work together towards a goal. Here is a simple outline of the implemented idea. It starts with the description of the working table and the SDG in text format. Meaningful words are extracted from the text, and the whole is represented in a knowledge graph, where the information of each node is extended with information from the stakeholder surveys. After creating the contextual data, we can perform link prediction on the graph to identify connection and make decisions. In general, we start with a stakeholder survey, in which all the information is made explicit in terms of interest and generalities. We use data from Horizon Europe program. In it, we have identified 6 clusters, plus 1 for research activities. Each cluster has different destination, which in our work represent the working table. Each work table contains a title and a mission description. In our preliminary work, we represent the work table where the description have an average length of 329 characters. This word related to sustainable development were extracted using a cyclical process. They were first extracted using domain experts, then the extraction process was refined using automated tools such as FastText to assess the similarity between word embeddings. Finally, we extract about 26 words on average, meaningful on each cluster. The initial graph represented on Neo4j consists of five entity types: SG, cluster, working table, keywords, and the stakeholder. In order to predict the connection between stakeholders, we also evaluate the projection of subgraph consisting of only stakeholder node. Therefore, we have considered the projection onto the entire graph containing all the entity described above to predict connection between stakeholder and destination, and between stakeholder and other stakeholder. Where the subgraph projected onto stakeholder, we only predict interaction between stakeholder. Not the embeddings were generated using a FastRP algorithm. Finally, three models were compared for link prediction. The prediction were evaluated using the metric area under the position record curve. And we found that the best prediction were obtained using information from the entire knowledge graph. Projection of the whole graph is more suitable for the prediction of the target relation. In general, it takes longer to train the link prediction model to work than to train the link prediction model work on. But this is justified by the fact that we have a significantly larger number of ages in that graph. In the future work, the aim is use different model parameters, add other data from other resources that add other information for stakeholder, and finally we want to provide an interactive dashboard that can be easily used by system dynamics expert. Now I will give again the word to Simona for the conclusion.
Thank you, Ilenia. Yes, we are just to say that we are working on the part on feature extraction, as I already said, and in particular to define compact descriptors to discriminate among multiple datasets. And we are also working to decision support techniques for the consumptions task to monitor the consumptions hydric and electrical consumptions. Okay, that's all. You may. Okay. Thank you very much. If you have any questions, of course we are here.
Thank you, Simone and
Dilenia.
Questions
from the audience?
I have to try.
Where?
Yes. Don't we have we meet in the middle.
Yes, I have one question from Simona. That is there any specific reason to use the tripartite graph?
Simona?
Yes.
You have used the tripartite graph shown in one of the diagrams. So is there any specific reason to take this?
I don't hear. Okay, we have used the tripartite graph, and then
why? Is there any specific reason why not multi-prite or bipartite? Only tripartite.
Well, because we would like just to consider the interactions between long non-coding RNAs, who are a group of nodes, and microRNAs, that are the other set of nodes, and then the associations between microRNAs and diseases. We didn't want to consider other interactions among these three sets of nodes, but just to infer the novel long non-coding RNA and disease associations by using this intermediate level. This was the main idea, and it seems that it works very well. So this is the reason why a tripartite graph and not other types of graphs, just to separate these interactions and associations between the three sets of nodes.
Okay, thank you.
You're welcome.
Okay, thank you again, Simone and Millennium.
And now let's go to the coffee break.
scappare per...
Domani mattina perché... so, cioè io ho fatto copia e incolla forse dal...
Sì, sì. Adesso
Massimo è di qua, Massimo.
Massimo.
Okay, good morning and welcome to this session, which is devoted to the topic adjustable green aware artificial intelligence. So we have a free presentation in this session. Before going into technical details, let's make a brief overview of the work package. So the general goal of the work package is the realization of artificial systems able to interact in a green way with the environment. So where for green is to be intended in a broad sense, as stated by Francesco, according to the sustainable goals of the United Nations, and also able to adapt to changing environment. Okay, so the task is, the work package is structured into 5 tasks, which are listed here. As for a single task, the first one is rethinking planning strategies and algorithms for a green society. This task is carried out by the DIMES Department of University of Calabria. And the main goals are to construct green-aware models for interaction between human and artificial agents, and also to take into account legal and ethical issues that arise when humans interact with artificial agents. Also, another objective is to design neurosymbolic system able to integrate the fast and slow thinking paradigms. The second task is adjustable green aware agents. This task has been assigned through a cascade call to the University of Salerno. And the interest here is investigating techniques like mechanism design, online learning, robust optimization, and sentiment extraction tools for designing adjustable green aware agents. Okay, the third task concerns adjustable green aware machine learning. This task is under responsibility of the NIMS department. Here the interest is in detecting deviating behaviors, both of human activities, artificial agents, or data sources, in the presence of green prescriptions. Also to be able to suggest compensatory actions of behaviors not compliant with green desiderata. Also to mitigate the impact of these strategies on the environment, since we are interested in using mainly machine learning and deep learning tools. Okay, so some of these activities are conducted in collaboration with the Lot company, which is an innovation grant partner under the project. Okay, the task 4 is green aware robot design coordination strategies. This task is mainly performed by the Department of Mechanical and Energy Engineering of the University of Calabria. The interest here is in sustainable materials and reducing energy requirements for innovative robot design. Recently, a cascade call has been launched, which is of interest of this task, with a company to Smartest for robotic case studies. And finally, last not least, the fifth task is trade-off in practical reasoning of greenware agents. This task is under responsibility of the High Performance Computing and Network Institute of the National Research Council. and in particular from the Palermo site of the institute. The goal here is to design a practical reasoner able to support green goal reasoning. Clearly, there are different challenges as be able to manage different kinds of goals and of reasoning. Okay, so as for the overview, that's all. And as previously stated, we have 3 presentations. So let's start with the first one, which is adaptive multi-round problems with budget optimization learning. The speaker is Diodato from the University of Salerno.
Thank you very much. Okay. We from the University of Salerno, we are in charge of the task about adjustable green aware agents, and the way in which we interpreted this task is to consider agent in a multi-agent system that is aiming to achieve some green-related task. But these agents are adjustable in the sense that they are dynamically changing, evolving over time. Just to give you an example of the typical problem that we are considering, we can consider the problem of adaptive selection of green energy provider. So we have green energy provider, but the provision of energy by of this provider is not deterministic. For example, it depends on the weather. If there is sun, there is wind, and so on. But still, there are facilities that are requiring some amount of energy, and they need to choose from which provider they have to buy this energy. And they have to choose this with strongly constrained on the budget that they have to spend for energy. So the problem is, how can the facility choose from which provider has to buy? And this may change from day to day because also the provision changes from day to day. Yet another example is a completely different example of is influence campaign in support of green behavior. So we have people, and the green-related behavior of these people can be influenced either directly by explaining to these guys that it is convenient for them to have a green behavior, and the reason for is this, and so on. Or they can be influenced by social influence because they see that their friends are behaving in some way and so on. But it is very costly to have direct influence. So we can have direct influence only on a few people. And the problem is how to choose these few people, and how to choose these few people in order that they have a strong social influence on the other peoples. So these are two kind of problems that we are considering. Apparently they are very different, but still what we show is that these two problems can be represented in a single framework of adaptive multi-round problems with budget, in which we have n agents. For example, the N provider of green energy, or the social relationship between peoples. Agents can be in a different state. These are the different energy production level, or the different way in which the relationship can be useful for influencing a person. And we have T steps. For example, the operation time of the facility, or the number of campaigns that we are running. And we assume that at each time step, the state of the N agent is drawn from some distribution. Okay, so it is not given. we make the simplifying assumption that the distribution at different steps are independent, but still we allow correlation between the state of different agents in the same time step. We have a budget B, and we have to decide how to allocate a fraction. For each time step, we have to allocate a fraction of the budget in order to probe some agents. Where probing some agents means buying energy from that provider or direct influencing some specific agent. And our probing is doubly adaptive. That means that we are adaptive both in the choice of how much budget we would like to use in this round and on which agent we would like to use. So we both, we can choose to save budget for the next round, or we can spend one more round and one more unit of budget in the current round based on what we observed. If we observe that the guy that we choose for buying energy is providing us a very low level of energy, we can decide to spend another unit of budget in this round, or otherwise we can save it for the next round. And we receive a reward based on the probed agents and on the observed state of the agents that we probed. And our goal is to maximize the sum over expected reward. Okay, what is known for this problem? And actually very few is known. And the reason is that no previous work considered this doubly adaptive setting. In all previous work, they are focused on either on a single round adaptive setting, so there is no adaptivity in the choice of the budget because there is only one round, and there are some hardness result and some approximation result, or there are work on multi-round setting, but all works in multi-round settings either consider probes that are not adaptive, or they consider that the budget is pre-allocated, and so there is no adaptivity in the allocation of the budget. And observe that this double adaptivity makes the optimum much more powerful. And so it is not clear if the previous approximation result stands against this so powerful optimum. But still, what we prove is that if the number of states is small, and the number of, if the number of states is small, the problem is fixed point tractable with respect to n. So this means that there exists a polynomial time algorithm, in particular it is a dynamic programming algorithm, that compute the optimal solution if the number of states is small and the number of agents is small. But and for the general case, we show that there exists a polynomial algorithm that achieves a constant approximation of the optimum reward, where the approximation is 1/2, 1 minus 1 over the Euler number. And actually, the algorithm is quite simple because we are facing double adaptivity with a double greedy algorithm. What this does it mean is that we are assigning greedily the budget to each time step, and for each time step we are choosing greedily which agent to ask. Where assign greedily the budget means that we choose to assign the next unit of budget to the step for which this goes the largest increment in the expected reward. And choosing greedily which agent to probe means that we assign the next probe to the agent for which this goes the largest increment in the expected reward. And how can we compute the largest increment in the expected reward? Simply by Monte Carlo simulation. Okay, very good. But in this result, we are assuming that we know probability distribution of states. So we know PDT. What happens if this is not the case? Clearly, our algorithm does not work because we cannot run Monte Carlo simulation if we do not know which probability distribution we have to simulate. So the question is, can we learn this probability distribution? And clearly it is not possible to learn this probability distribution if they change at each time step. So let us make the simplifying assumption that the probability does not change. What happens? Can we achieve good performance even if we do not know from the beginning this probability distribution? And the question is how to measure this. And what we do is to put ourselves in the online learning framework. So we have our algorithm, and we compare the performance of our algorithm in the long run over the t steps against the performance of the optimal algorithm that knows the probability distribution. And the measure that we use for comparing the performance is the concept of alpha approximate regret. So this means that we compare the performance of our algorithm against the performance of an alpha approximation of the optimal algorithm. And when this value is small, this means that this is a measure of how much we are losing over time with respect to this alpha approximation of the optimum. And the goal is to achieve alpha as small as possible and to achieve this regret that is sublinear with respect to time. That means that as long as the time increases, the number of wrong choice that we are doing is becoming smaller and smaller. Okay, ideally what we want is that the regret is constant with respect to the time. And so what we achieve? Actually what we achieve is that there is a polynomial time algorithm returning exactly the same approximation that we are able to achieve with the full knowledge of the probability distribution and constant regret, so the ideal goal. And the algorithm that achieves this is quite simple. What we do is to keep empirical probability with respect to the states that we are observing in our dynamics. And we run an exploration phase in which we choose completely at random which agent to probe. And after that, we run an exploitation phase in which we use exactly the same algorithm that I described before for the case of full knowledge of probability distribution, but we run that algorithm against the empirical distribution that we collected. And what we prove is that a constant number of a constant length of the exploration phase is sufficient to achieve a good approximation of real probabilities. And the approximation algorithm that I described before is able to return a good approximation of the optimum, even if it is run against this close approximation instead than to run against the real probability. So, very good. So let us deploy this algorithm and let us use this algorithm. Actually, there is a problem. This algorithm requires a lot of Monte Carlo simulation, too many Monte Carlo simulation. This means that running this algorithm, even if it is polynomial time, requires too much time, even for small input. So what we did is to provide an alternative algorithm, an heuristic algorithm, that allow us to reduce a lot the computation time. We go from 13 hours to 32 seconds. And still, we have experimental results showing that this converges quite quickly to the 1/2, 1 minus 1/8 approximation. So, this is just the beginning of this line of research. There are a lot of other interesting questions. For example, what happens with what we assume that probability are independent. PDT, the PDT are independent. What happens with the correlated PDT? What happens if the cumulative reward is not just the sum of the single step reward? What happens if the budget is not known at the beginning, but it is accumulated over the time? What happens if we make learning with some noisy distribution? So the distribution is not exactly the same at each time step, but there is some noise. There are a lot of other questions, and from the technical point of view, there are algorithms that are practical, like the one that we described here, and for which we can prove quick convergence to the objective with formal guarantee. Actually, for this algorithm, we only have experimental simulation. And that's all. Thank you.
Thank you. Questions? So I have a couple of questions. One is regarding the fixed parameter tractability. Yes. Did you consider also different kinds of parameters, for instance, relating to the topology of the networks or something like that, besides the say classical n parameter? And the second question is if you have any idea why after a constant number of runs you go quite close to the final result. You mentioned something like that.
Okay, for the first question, yes, we do not consider it. Actually, what happens is that there is this very natural dynamic programming algorithm, but this dynamic programming algorithm depends on the efficiency of the single step. So how it is easy to solve the single step. So the idea is, let's start to solve the last step, in which there is no future budget to save. And let's see what happens for the last step, and let us solve the last step for each remaining budget. Okay? So once you have done with the last step, let's go back and so on. So the bottleneck is the efficiency of resolving the problem for the single step. And actually, this problem depends on how much large is the input. Clearly, this is polynomial time when n is small and when the dimension of the input is small, but is bounded. Yeah. It's polynomial time when these numbers are bounded. Yes. So for the first question, we have not considered, but we think that it will be very hard to. So there are other measures, but the idea is we need that the single instance input is small. So n is one of the input, the parameters that we can use for keeping this value small. There are some other value, but the idea, the problem is that one. So it does not make sense to enlist all the ways in which we can keep this value small. The second question is about, let me...
The fact that after...
okay, yeah. It actually depends a sort of Hofding bound. It is quite, it is a bit technical, but it depends a sort of technical bound. Okay, here the constant is with respect to the time, t. So constant is not constant on other parameters. We are constant with respect to the time step. So actually, the length of this exploration phase depends on the number of agents and on some other parameters. For example, it depends on the size of the graph for the influence setting. Okay, so it is constant only with respect to the t.
Yeah. I'm wondering whether there is something strange that should be understood yet to explain why for this kind of.
No, okay. No, because you can learn. Actually, the idea is that the distribution that we are learning does not depend on t. So it is sufficient something that is independent of it. What will be interesting is try to keep the length of this exploration phase smaller, even with respect to these other parameters. And this is what we have not done in our work. And actually, this is also the reason for such long time, this long time in the running of the algorithm. Okay.
Okay. Thank you again, Diodato. And now let's go to the next presentation. The title is Catalina, a cognitive agent practical reasoning architecture. The speaker is Massimo Cosentino.
Yes, here I am. Good morning, all. Let's start. Here it is. Okay. I'm here to present you the first release, actually, of our architecture that was part of the plan of this task. So the task is the 955, and the aim was to develop, in fact, an agent architecture with some interesting and novel feature, actually. Consciousness. Consciousness is an open problem today in cognitive science. What is the right model for consciousness, for artificial consciousness, is not defined today in literature, and this influenced our work a lot, and I will tell you something later on. Also, another pillar was practical reasoning, but taking inspiration starting from the classical Bratman model, we enlarged that introducing partial goal satisfaction. That was an idea already in some of the Bratman papers, but never developed actually, to the best of my knowledge, in any architecture. And finally, of course, the reason the task is here is green goal reasoning. The idea was to have an agent that was able to consider green goals in its reasoning. So that's the team, 5 people at ICAR, CNR, in Palermo department, 2 staff, me and Giovanni Pilato, and then we have another researcher, Guido, and 2 others assistants. We had the recruitment phase has been quite long. Actually, this influenced our work. We have the external collaborations with 2 Canadian universities, Professor John Milopoulos and Mirto Milopoulos. Professor John Milopoulos is a computer scientist, well-known computer scientist, and Mirto is a philosopher. She works with Professor Rosenthal, that is one of the main authorities in consciousness and research about consciousness. So she is a professor at the Carleton University, where they make research about high-order theories of consciousness. So it was determinant to have her in our team. About consciousness, this is actually the first part because it's at the infrastructure level. So we spent a lot of effort by now in the consciousness, in the definition of the conscious aspect of our architecture. And we decided to remain some way neutral for the kind of conscious model we implemented. By now, we started with the first model, and we plan to introduce the high-order theory, because we have Mirto with us. The first step includes the support for 2 well-known theories, BARS, Global Workspace Theory, together with the Buehler's executive system theory. I will talk about that in the next few slides. And considering that from a computer science point of view, we studied a lot of papers in the area, and we tried to extract requirements for our architecture. This requirement became design choices, and influenced our implementation. For instance, we decided to implement, of course, quite a simple choice, the global workspace as a publish subscribe dashboard, processing incoming messages and sharing information with the other functions. We decided to spend some time on the definition of an algorithm for attention modulation. Attention modulation is a concept that is some way shared between both Bars and Buehler theories, since in the Bars theory we have the concept of spotlight that illuminates a part of the knowledge of the short-term memory, while in the Buehler's theory we have attention modulation that is used to inhibit regions for perceptions, inhibit goals that are not relevant at a specific moment, and so on. So attention modulation was an important feature for us. From Buehler's executive system theory, actually Buehler's theory says that consciousness arises from the complex interaction of several functions. We decided to implement a few functions. You will see that later on the architecture. And here again, we had some inputs from the requirements coming from the study. And for instance, we decided to spend our attention on the implementation of the mechanism that translates desire, that promotes desires. Let me explain a little bit better. We are talking about a software agent. So there is an analyst, a designer, that injects some goals in this agent. When the agent starts its life, has some goals that it has inherited from the designer. In the future, we also plan to support runtime injection, because we had, in the past years, we made a lot of work on runtime injection of goals, so we plan to reuse that experience. Anyway, when the agent has a lot of desires, it cannot pursue all of them at the same time. So there is some filtering mechanism that is the endogenous desires activation mechanism that filters which desires should be considered for planning and then eventually considered for deliberation as an intention. So we added one more layer to the classic Bratman process. The same for exogenous desires, desires that are triggered by perception. So this is important because the agent acts in the environment, so it receives perception, and the perceptions may trigger desires. Here, when talking about exogenous, we often talk about epistemic goals, the need for the agent to understand something in the environment and react according to that. We prefer to split epistemic goals from functional goals. In several implementations, they are together, but they are different because a functional goals aim to change the environment. So the state of the world will be changed when the functional goal is successfully pursued. Differently, an epistemic goal aims to change the mind of the agent. The agent wants to know. The change is in the knowledge of the agent. So they are different, and also our algorithms for dealing with that are different. Okay, I skipped some details. For instance, the inhibition regions that mask a part of the perception for the agent. When we look around, we focus our attention. This means that we perceive a portion of the environment, and only important salient stimuli are kept from the other side, from the border side. For instance, a movement. Also, if we focus in one direction, we can perceive a movement in another part of the environment. But these are other concepts. Green goals, arriving here to green goals. Green goals become a first level category of goals for us. This is different from any other architecture that I know. A green goal is different in its origin, first of all. It doesn't come from the designer, but likely from some kind of high-order authority, for instance, the government, a law, or some kind of social convention, something like that. So it's not negotiable. While for all the other goals, we are studying algorithms for pursuing partial goal satisfaction, and I will not go into the details of partial goal satisfaction today. I hope to be here in a few months in our next workshop and talk about partial goal satisfaction. Too many arguments for just one talk. And green goals are not subject to partial goal satisfaction, because if there is a law, I must obey entirely to the law, not only to a part of the law. It's not negotiable. And of course, we also implement a mechanism of rewarding or penalty when the agent violates a green goal. Example of green goals we are considering in our first implementation of the Catalina architecture. They are here reported about pollution, avoiding congested roads, and so on. These kind of goals are some way qualitative, and we needed to operationalize them. And in order to do that, we referred to a theory from John Minopoulos, one of the persons involved in this architecture, and Giancarlo Guizzardi. They developed a theory for operationalize quality goals and qualitative goal, let me say, not quality, qualitative goals. And they introduced the idea of refer to an ontological representation of the domain and introduce quantitative constraint. So we made this infrastructure, we supported this infrastructure in the architecture, and we introduced quantitative constraints for allowing the agent to reason about the violation of a green goal using numbers, of course. So here is the architecture. Let's see. It is mainly composed of a center element that is the global workspace coming from the bars theory. Here we have all the knowledge that is part of the short time memory. The global workspace is a short time, is a working memory, while we also have a long-term memory for saving information that is not needed in that specific moment. And an important task of the global workspace is the broadcasting of information. We implemented a reasoner function that is, of course, inspired by the Bratman classical reasoner. Here we have a means and reasoning module for calculating the options, the plans that the agent may use to pursue some intention. We have an opportunity analyzer and so on. Some way similar to the Bratman architecture, but as I said, here we are developing and testing in these days, actually, the partial goal reasoning techniques. We have different algorithms for functional goals, for the partial satisfaction of functional goals and qualitative goals, because they are different in nature, so the algorithms are different indeed, quite different, with different persons also involved in the work. And here, an important part, the switching function implements the attention modulation. For instance, this means that here we have an algorithm for selecting which desire should be passed to the reasoner in order to try and find plans that can be perhaps useful for pursuing that specific desire. And exogenous attention modulation regards the stimulus coming, the management of stimuli coming from perception. If a stimulus is salient, is important, is vital for the agent to promptly react, this allows us to promptly react to this stimulus. The inhibition function, as I said, takes care of masking part of the perceptions that are not relevant for the task at hand. An example I use, I hope it's clear, one of the examples we implemented is an autonomous guiding vehicle. When the car is going straight ahead, it doesn't take care of what is reported by the back camera. It's not important to process the images from the back camera continuously. From time to time, it looks back. While if it is going back, of course, it's the reverse, so it processes the information from the back camera and not from the front one continuously. So this is the inhibition, and the resource allocation, let me confess, it's the part that I don't like of our current implementation. It's just an execution layer. In my idea, in the future, it will be an adaptive workflow engine. We made some experience in the last decade about adaptive workflow, and I plan to reuse our experience about adaptive workflows, because here I see an adaptive workflow engine that can react to the situation and adapt the plan. As finally, okay, the memory maintenance function takes care of synchronizing the short with the long-term memory and maintain the information. For instance, decoding of memory information and so on. Okay, here some of the most important algorithms we defined. Actually, I already introduced them during my previous slides, so I skip them. Let me spend a few slides on attention modulation. That is one of the important mechanisms in a conscious system. Here we have two mechanisms, top-down and bottom-up. The top-down regards the endogenous desires, so functional goals injected by the designer are processed in a top-down way. The agent must pursue them as soon as possible. But in pursuing them, perceptions arises, and the agent must react to them. So we have a kind of bottom-up process dealing with exogenous desires. Mainly, as I already said, epistemic goals. This means something is perceived in the environment, the agent needs to understand, and if this is the case, it needs to react. Here is an example that I will explore a little bit. It's an autonomous vehicle. Okay, let's start from the bottom, here from the analyst, that introduces some desires in the agent, for instance, go to town X, Y, Z, and so on, with some saliences. This means that some goals are more important than others. At the beginning of its life, the agent deliberates which is the most urgent, or because also I talk about urgency because we define functional goals using linear temporal logic, more metric bounded temporal logic. So time is important, and urgency maybe is part of the decision process for deliberate which is the most important desired specific moment. So the agent may, for instance, select, here we have one algorithm, the endogenous attention modulation algorithm, and one desire is selected, go to town Y, for instance. We are following the blue line by now. This passes through filtering, the calculation of options, plans. So we have some option, take some road, turn right, and so on. The deliberation process, we suppose, decides, okay, that's the time for doing that. This becomes an intention. The intention is a desire with an option, so a plan for actually doing that. The agent focuses on that. From this time on, all the other desires that are less important are neglected. the spotlight becomes very, very small, just concentrated on one set of actions, on some information that are relevant for that. This has an impact on the green side, because we are optimizing, by the way. This is a part of the work we are going to do in the future. We are not processing everything continuously and so on. We focus on what is really needed at that time. And so we suppose the agent is acting in the environment, and perhaps while the vehicle is going around, it perceives something that is strange, black smoke ahead that is not normal. It may be dangerous. So this raises, first of all, this is a belief, a new update, a new belief. This is stored in the global workspace, and according to the mechanism defined by bars, the global workspace shares the information to the registered functions. Some function reacts to that, and we have an algorithm here, the exogenous attention modulation algorithm, that may select this as an important stimulus. This triggers a desire, and here we are now following the red path. We have a new desire, that means find what is the cause of this black smoke. The agent may react, for instance, with an option that consists in contacting some traffic information service and so on. The loop goes again as before, not significant. So future works, we are working on the reasoner function. The consciousness part is some way done for the Bars-Buehler's theory. As I said, we are already studying the paper of Rosenthal by Rosenthal for the other high-order implementation. We are completing the algorithms for partial goal satisfaction. We are testing and tuning a few parameters. And so in the very next future, we plan to implement these algorithms and also tune a few parameters about attention modulation, because the function that defines the saliency and then the reaction, the attention modulation for the agent is sensitive and is important. We are performing some experiment about that. Okay, that's all. Thank you for your attention. If you have any question, I'm very happy to answer.
Thank you. There is room for a short question.
Sorry, I took a couple of minutes more.
Okay, no questions. Okay, so I have a sort of curiosity.
Yeah.
So maybe the question is not very appropriate, since the system is a practical one. Okay, but there is some study concerning complexity, computational complexity, or some constraints.
Not part of this work, indeed. Actually, in our experiments, we have no specific criticalities from that point of view. So execution time are acceptable, more than acceptable, even with the normal, let's say, machines. We have not computed the convergence, for instance, and studied the complexity of the algorithm specifically. But anyway, we are on the simple level, so it's not an issue by now. Thank you.
Okay, clear. Thank you. Thank you again to Massimo. And now let's go to the last presentation, which is explaining anomalies through semi-supervised autoencoders with applications in manufacturing defects localization. This is a joint talk by Simona Nistico from University of Calabria and Davide Zicca from Deloitte, the Deloitte company. Please.
Good morning to everyone. Anomaly detection, which is the subject of this presentation, represents a crucial task for many application contexts such as healthcare, cybersecurity, and so on and so forth. And many of them deal with sensitive use cases where having some insights about why a certain object has been pointed out as an anomaly is useful for decision makers because help them to make timely and effective action as a response to the detected anomaly. But unfortunately, the models that are nowadays used to deal with the anomaly detection task are really complex, and for this reason are unable to provide the required insights. And this is the reason why they are said to act as black boxes. The explainable artificial intelligence research field aims at fulfilling this need for transparency by proposing solutions that tries to open the black boxes. In the literature, there are many methods dealing with classification and regression as well, but unfortunately, less work has been done on the anomaly detection problem, which poses additional challenges to the problem of explainability, which relates to the peculiarities of this context. For example, in anomaly detection, we have outlying data, which is rare and peculiar. And for this reason, the standard XAI algorithms are not directly applicable. When we talk about explainability, what we have is that the most commonly used approach involves post hoc explainability, in which we have an already trained black box model for which we want to explain the observed outcomes. This kind of approach is good because it's broadly applicable, but unfortunately only provides an approximation of the real model behavior. This is okay in many applications, but unfortunately when we deal with sensitive use cases, we want to obtain faithful explanations. And for this reason, we need a shift in the used approach. And this is also the reason why in this presentation we consider another kind of approach that is known as explainability by design, in which the explanation is embedded inside the model. And in this way, we obtain a perfect match between the explanation and the real model behavior. Additionally, this kind of approach allows to consider also other things that are, for example, green objectives, but also helps to provide additional guidance to the model from the data that we collect, for example, on the domain expert side. And moreover, this allows also to consider more lightweight architecture thanks to the supervision that is provided by the additional data that can be considered. The method that I will present to you today is named XAD, and of course it is tailored to yield models equipping by design the prediction together with the explanation. And in particular, the leading idea of this approach is to make autoencoders able to provide explanations. And this is done by considering an objective that promotes that the normal features are reconstructed well, while in the objective, the anomalous features should be reconstructed as bad as possible. In the rest of this presentation, we will deal with image data, and for this reason, hereafter, we will refer to the features as pixels. During the training of XAD, we consider a set of, in this case, images containing normal images and a few anomalies. Each of them coupled with a ground truth heat map locating the anomaly inside the anomaly or the anomalies inside the image. Then to perform the autoencoder training, we consider the loss that you can find into the slide, in which we have two contributes. The second of these two contributes take care of anomalous pixels, and in particular measure the squared difference between the reconstructed value for the pixel and the value that we obtain according to a function f, which is devoted to badly reconstruct that pixel. In particular, in the experiment that I will present to you later, the kind of function that we have considered is that mapping to 0 all the pixels having a value greater than 0.5 and to 1 all the remaining pixels in order to maximize the observed error. This contribute is divided by the maximum observable difference, which is given by the difference between the original value of the pixel and its mapped version. Differently, the first contribute of the loss take care of normal pixels and in particular measure the squared difference between the original value of the pixel and the reconstruction provided by the autoencoder. This term is also divided by the maximum observable error for that pixel. After the training, so at inference time, for each item, we first of all compute the reconstruction provided by the autoencoder for that image. And after that, XAD computes the pixel-wise reconstruction error, which is again divided by the maximum observable error in order to make the error of each pixel comparable. After that, these pixel-wise differences are used to compute the normalized anomaly score, which sum up all the observed errors. And after that, we perform an additional step which allows to obtain a binarized version of the heat map. In particular, the binarization is performed considering the mean and the standard deviation of the reconstruction errors observed on the train set, and we have that each pixel is pointed out as an anomalous pixel if the observed error is far from the observed mean of at least n standard deviations, where n is a threshold that can be set in order to obtain different levels of sensibility of the approach. Here we have an example of how XAD works. So in the slide you can observe an input image. In particular, in this case, we have a cable structure containing inside 3 cables, and in particular this represents an anomalous image because one of the 3 cables is missing. Here we have the reconstruction provided by the autoencoder. You can observe how the region in which there is the anomalies provided by the missing cable is reconstructed as a white portion. This is due to the function f, which promotes to reconstruct that anomalous region as having all pixels equals to 0. Here there is the raw version of the heat map, in which the more the pixel is anomalous according to the autoencoder, the more yellow are the corresponding pixels, and we can notice how the most yellow region is that which represents the anomalous part of the image. Here we have a refined version of the heat map obtained by applying a blurring operation, which can be provided to the user in order to improve visualization. And here we have the binarized version of the heat map, where the only part of the image pointed out as anomalous is that referring to the missing cable. Then, to assess the quality of our proposal, we have performed some preliminary experiments considering synthetic datasets. In particular, we have considered the MNIST and FashionMNIST datasets, and we have injected into them some artificial anomalies, which are obtained by taking some images from the dataset and then adding a 3x3 gray square inside the image. And in the first row of the picture, you can find the anomalies inserted into our artificial dataset. In the second row, you can find the ground truth heat maps locating the anomalies inside the image, while in the third row, we have the heat maps provided by AXAD. You can notice how comparing them with that provided by standard autoencoders, which we consider as a baseline, and two other competitors, which are SCDD and DEMNet, AXAD is able to produce a more precise localization of the anomaly inside the image. In order to have also a numeric measure of the quality of our approach, we have also computed, considering again MNIST and FashionMNIST datasets, the pixel-wise AUC, computed considering anomalous images. In particular, you can notice from these results how, concerning the MNIST datasets, AXAD is able to always achieve the best performances, while if we consider the FashionMNIST dataset, it almost always ranks first, and when it not happens, it ranks second, showing only a little difference with the best performing approach that in particular from the results that we have collected is SCDD when AXAD not ranked first. After the presentation of this first experiment, I give the floor to Davide, which will present the practical part of this presentation.
Thank you, Simona. Thank you, everyone. We are going to see now how to combine this anomaly detection technique with a system prototype, which is actually a user interface that can be applied to many industries. But here I want to focus your attention on the manufacturing defects localization. And here we're going to see our interface. So the interface is quite easy to use. It gives a lot of information to the end user. And for instance, it gives the possibility to select the best model according to the data that will then be uploaded to the interface, and then it also gives a description of the model that then is being used. Again, here the interface very easy to use, and it also allows the end user to manage the model in the sense that it gives the possibility to adjust the sensibility of the anomalies that then will be displayed in the final report. Here we can see the possibility to upload, for instance, images. So we thought to apply it in a scenario in which we have a line of production, and the end user needs to understand if there are anomalies in the already produced materials. And here we can see some KPI. For instance, we have the possibility to rapidly understand the percentage of anomalies that are available in each pieces that has been produced, And then another important part is the percentage of the surface of the damaged pieces, because in this way it is possible to rapidly stop the line of production. Finally, in the report we can see that we have some graphs which are very, very useful and easy to understand. So for instance, the heat map that is already been explained by Simona. Here we can see the surface of the anomaly. And then for sure we can also construct a lot of graphs that can help the end user to understand, for instance, the amount of anomalies that are being produced, and if these anomalies are over a threshold that here is been just for a simplification applied to a static threshold, but of course it can be modified according to the knowledge that the end user have about the data and the pieces that have been produced. Here, as we can see in this slide, there is the application of the autoencoder technique over some other input data. So for instance, we have the bottle, the cable, but also other industry, as I said before, can be used with this algorithm. So for instance, the food sector, we can appreciate, for instance, in the hazelnut image, in which we have the ground truth, and then below we have the heat map about the autoencoder, and we can really appreciate how this model performed thanks to the area under curve matrix, which gives here a clear understanding of how well performed the model. Here again we can see the detection area. So the detection area is something really which is combined with the sensitivity that we can give to the model. So for instance, here we have the binarization, and we can appreciate, for instance, in the top 3 images on the right of the slide, that the ground truth actually is narrower than the detection area, but this is due to the sensitivity that have been given to the autoencoder model. For instance, we can appreciate that in the below 3 images we have the real image, and then the detection area, which is quite narrower and very similar to the ground truth images. So finally, we want to focus your attention on some sector that can be in which we can apply this anomaly detection algorithm. So for instance, let's imagine an energy sector in which you have to manage your assets, and essentially you want that your assets will always be in the best condition possible, so in order to have a high level of operativity. So in this case, we can use these anomaly detection algorithms using camera systems that are able to detect anomalies rapidly, and so eventually you can prevent incidents and have a positive impact on operating costs. Another sector that I want to focus your attention on is the electronics one, because here the possibility that the human can fail is very, very high, because the defects on microcomponents really imperceptible to human attention. So using, in this case, high resolution images, it is possible to verify if there are some anomalies, and in this way you basically reduce the warranty costs and strengthen the brand reputation. Finally, we have the final conclusion. Simona, please.
So to wrap up what we have said in this presentation, we have presented a method which deals with the problem of explainability by design in the anomaly detection task, in which leverages autoencoders to produce together predictions and explanation, and in particular the experiments that we have carried out showed how the EXAD approach results to be promising in achieving more precise defect location, and also to have more trustworthy results.
Thank you, Simona. We just want to focus finally the attention on the fact that combining anomaly detection technique with user-friendly interface, it is possible to reduce risks, and it is also possible to apply this model over a variety of industries. Thank you, everyone.
Thank you. Any question? Please.
Mm-hmm.
I not completely understood. You use autoencoders.
Yeah, yeah.
And regarding the topology, the architecture of the autoencoder, which is trained with a specific loss function in order to help to make explanations for design.
Yeah, yeah.
Just one layer. And the second question is regarding, probably, as I understood well, you use the approximate images in order to make this anomaly detection. But is there any information regarding the anomalies in the complexity of the interpretation?
Okay, thank you for these nice questions. So regarding the first question, the approach that I have presented to you today is general, so it can be applied to any autoencoder. But in particular, in the experiments that we have performed, we have used a convolutional autoencoder with 2 convolutional layers, if I not remember wrong. But it can be applied also to other kinds of autoencoders as well. Regarding the second question, we have considered a set of pixel level labeled images. So the knowledge about the specific problem is encoded inside the labeling. So we know through the labeling which part of the image is defective in the particular application, or in general is anomalous or not. So this is the kind of information that we use for the training. You're welcome.
Thank you again. And this is the last presentation of the session, so the session ends here.
So we go for lunch. Outside there is this restaurant Cubo, just here on the right. So we will restart at perhaps a 2:15, if we are able to anticipate a little bit. definizione in inglese.
Sì, questa qua che infatti stavo vedendo che stava trascinando.
Questa?
Questa
Due?
qua sì, era al posto sì, della 3. Sì, perché quella era la versione italiana.
E adesso iniziamo, eh? Sì.
Sì, sale.
Aspetta, Digitwin, ok. Questa? Perché quella è aggiornata. Ok, ok. Sì, no, ma io nel dubbio l'ho tenuto tutte e due. Tanto poi quando è il momento. Intanto i relatori di salire qui, tanto abbiamo spazio, quindi così andiamo più veloci. Ecco. We are ready to start. So we will have a short pitches, 5 minutes each, from the companies that joined us. I think we have some very interesting projects, and I encourage all of us then to join them in the poster session in order to foster collaborations, to share ideas, and that's our main goal of today. So we will start with Revelis.
Thank you. Good afternoon, I'm Davide Jacopino, data analyst for Revelis, and today I'm going to introduce the Industry 5.0 collaborative platform. First of all, a brief introduction of our company. So Revelis is an innovative SME that offers AI solution for big data analysis. We operate in vertical markets, including banking and finance, IoT intelligence for manufacturing and smart cities, and also we provide solutions for utilities and public administration. We are deeply embedded in a broad network of industrial, academic, and R&D partnerships. The industrial context of our platform is the one of an industrial bakery named Target. Target produces a wide range of products, baked products, so for example bread, pizzas and snacks. Some important notes. The first one is that the production process is divided into three different phases: production, ovens, and packaging, each corresponding to three different departments of the three areas named on the slide. Because of the structure of this production process, there can be a wide range of temperature into the working environment, so situations of high physical stress of employees can occur. Moreover, workers can perform equally in each department, so they are interchangeable, and customers can ask customized products to Target. Okay, here in the slide there is the architecture designed for this platform. Is an IoT infrastructure where smartwatches and environmental devices collect biometric data from workers and of the work and work environmental parameters. These data are used for two main goals. The first one is to monitor and predict stress condition of workers in order to optimize workforce scheduling, trying to prevent situations of high stress of workers, and also suggesting changes in case of high stress situations. And this task is performed by different components in the architecture. The first one is the stress prediction algorithm. That is a machine learning model that predicts the future values of future stress values of each worker. The second one is the assignment algorithm. That is an automatic reasoning component that generates a new work shifts, so a new scheduling for workers. And another important part for this goal is the Grafana dashboards that are integrated into the platform. The second goal is to support the mass personalization of products in order to answer to customer requests. Okay, let's go on the advantages of this platform. The benefits for Target are to improve workplace safety and working condition by preventing high stress situation of workers, and so also optimize productivity through stress reduction and also through smart automation of some parts of the production process. And also to increase market adaptability and competitiveness through the mass personalization mass personalization component of this platform. The last one is to integrate workers, devices, and automation by creating an Internet of Everything platform. Moreover, we aim to develop an innovative, versatile and scalable platform for Industry 5.0 in order to integrate new functionalities and so to allow the personalization of this platform on specific needs of our customers. So Target acts as the first validation context in real world, in industrial world, but then we would like to create an innovation ecosystem collaborating with new partners and new customers in order to accelerate the development and adoption of Industry 5.0 solutions. So here are the contacts, and thank you for the attention.
Thank you, Stefano. Now it's the time of fifth ingenium, please.
Good afternoon. Hello, good afternoon. I'm Matteo Valeriani. I'm the founder and CEO of Fifth Ingenium. Fifth Ingenium is an Italian company specialized in augmented extended reality. Thank you. Combining with machine learning. In the last 7 years, we developed several projects and products in the industrial field, in the educational field, and IET want to combine exactly these two aspects. So what is the IET project? We want to try to mixing the potential of a AI conversational agent to support the training of the on-field workers, especially when they work with the complex machinery or complex procedure that have to be very accurate, follow the procedure, or without possibility of error, or also with a big risk for their safety. So on the end, so we want to work on supporting this on-field worker, giving them an easy way to access the information during the training phase, and also on-field having a real-time feedback and potentially the support of a remote trainer when they are in the factory line. So again, one of the important aspects for us is try to maintain the safety environment, as much as safety environment for on-field worker. For this reason, we think that having an agent that support or using combining at the same time augmented reality, so having the information in front of the eyes of the worker, and at the same time having the full access to a huge knowledge base, can help them to reduce the error and try to improve their daily activities. So training is one important aspect. We point to increase the efficiency of the training, combine simulation and agents. We try at the same time to give a personalized path of training for this worker. A lot of times the on-field worker have problem with language of the instruction, so we try to support them from using multi-language approach. At the same time, try to adapt the learning path based on the step achievement during the simulation. And of course, we try to keep the user-centered design approach. So we try to involve the final user, the on-field worker, from the design phase to the final testing and deploy. The project is just started, it's just a couple of months. The first part of the project will focus on design, exploring different model and possible integration for the future application. Of course, we started from a big dilemma for everyone here, on-premise versus cloud. For our target, the industrial company, on-premise solutions is becoming the goal for all their architecture. So we try to find a flexible solution that can be deployed on cloud, typically on token as a service infrastructure, but then later on scale up on their own data centers. In particular, we now figure out an architecture based on a semantic relational database on the one side, one storage for files, typically Magna, combined with the Postgres vet for the embedding. The general framework we are going to use is Olama, that allows to scale both on cloud and on data center at the same time. And we're working a lot on testing several models, combining that to achieve different functionalities from audio generation, image recognition, video, and so on. Here are just a couple of examples of a small demo we start to create. This is a virtual environment where the user can start to interact with the agent, like asking, for instance, describe this machine. So without specify what they have in front of them, they just say, oh, what is this? So, and the system understands the model in front of the user and provide description and information about that. Or again, you can ask to identify component inside the simulation, the 3D model that you have, in this case, which is the 6-level wash car model. So again, also in complex definition, the system starts to highlight the model. And of course, when you ask more information, the system automatically retrieve the information from knowledge base, going to the link to the PDF or videos or other material they include in the knowledge base. We start also to discuss with the final user, so it's important for us to involve the final user in this process, and we identify very specific moments that are very critical for them. So of course, having the having a hands-on on 3D model for them is complex from one side, but at the same time help to test and training before going to production line, especially for complex assembly or for projects that are not produced every day, and this is very important for them and for their reduction. Of course, this is only the first step. We are going to improve and extend our analysis with the users. At the same time, we are consolidating the architecture model, and on top of that, we are going to develop 2 POC for training with 2 different companies, try to testing on field the final result. Thank you.
Thank you, Matteo. For the questions, we have the poster session later. So now, Dune, please.
Prova. Okay, so hello everyone, I am Emanuele Persiano. Now I'm going to introduce you to the first part and the beginning of the project WISE. I'm a data scientist from Dune, which is a company that offers solutions in the tech field, for example, IT systems and software development, gathering and managing of data, and so on. And what is the WISE project? First of all, WISE stands for Wide Application of Intelligence System for Equipment, and it offers to give a new, efficient and effective way to manage industrial assets with the application of anomaly detection and predictive maintenance through the use of artificial intelligence in order to improve the KPI performance, business performance, and sustainability performance of companies and in general of industrial assets. The main focus of the WISE project is going to be the use of audio data gathered from and collected from the machinery. As you can see in the slide, there is a wide and cooperative team of the different main actors of the value chain of the industrial assets. From one side, we can find the development team, our team of Dune, which apart from me comprehends Chiara Puricelli, Rosario Morbegno, Michael Laucella, Boris Saracino, and with the collaboration of Pietro Marinelli. Then there is the Unical research team with the Professor Domenico Ombrello, Giuseppina Ambrogio, and the PhD Stefania Ferrisi. And then we have the domain experts, our domain expert in which we collaborate, this is Kosberg. WISE is divided into 3 different working packages. The first one is the feasibility study, then there is the research, the industrial research, and then there is the final study and development. Which was the starting point of this project. So it was a conduction of a laboratory experiment from the research Unical team. It is a predictive maintenance study on a milling machine. This machine was made from a tool with 5 different inserts that, guess what, milled some wood plates. And then at each milling movement was associated an audio track There was conducted 4 different campaigns with different machine parameters, such as speed and depth of the milling process. And on these 4 different campaigns, a total of 1,025 audio tracks were recorded, in which were extracted both numerical features and images in form of spectrograms. And then at each image, it was at each audio track was associated measure and then calculated a different level of wear. As you can see in the pictures, in the top left corner of each image, there is the different level of wear that then was measured and then interpolated. A different level of wear then have been associated, as you can see in the picture, using this Taylor curve at different classification levels in 3 different areas. In the first area, we can find the initial wear region, then the steady state region, and then after the critical point, the failure zone in which we don't want to enter. And then all these different machine parameters and the feature extracted from the audio tracks were used to train machine learning and deep learning models to then forecast from one side the classification level, so it was a classification problem from one side, and then the remaining useful life of the tool, of the machine, so a regression problem from the other side. The most promising algorithm, if you are guessing, is a deep learning model that is the CNN. So which are the objectives that this project aspires to reach? First of all, an increase in the productivity, because of course the number of downtime is expected to be lower. So this brings a reduction in defects and scraps also, and a decrease of emission in CO2. And the decrease of also sudden accidents is going to reduce the number of incidents of the workers, and then the workers are going to have a collaborative tool that is going to increase their level of satisfaction and also their productivity. All these things combined together are going to decrease the maintenance costs, so this is expected, but of course, with all the things cited before, there is this expectation, and also a technical improvement and innovation because of this new methodology that are going to be brought in this industrial environment. Of course, there has been some issues, some things that we need to try, we need to solve. First of all, the audio signal acquisition was manually recorded and manually post-processed. Of course, in a production environment, this needs to be automatized, and at each milling movement, or in general, at each movement of the machine is going to be is needed to be automatically assigned an audio track. Then it has been tried to process all the audio tracks directly instead of using the spectrograms, so the images, but since it was used a local computer, the performances required were very high, so it was not successful. So what we are going to try is to use a cloud-based environment, which makes it at our disposal a lot of high performances machines that of course we need to monitor because of the high costs that these machines can brought, and also the high impact on the environment. And then in general, last but not least, we need to deploy this experiment in a real world scenario, so we need to decrease as possible all the impact that this project has on the productivity of the machines. Another important part was the identification and the joint design with the domain expert. In our case, it's Cosberg, which is a company that designs, engineers, and built all these modular machines for the process automation in the assembly field especially. And we analyzed the case study, and especially we highlighted all the possibilities of these projects, which conducts of all the KPIs and that I mentioned before. And so they make at our disposal this beautiful machine that you can see in the picture, which is a modular machine composed of 6 stations, in which we are going to replicate the lab experiments of Unical, of course tailoring all the process in a real-world scenario. So as I explained, it was just the beginning of the project with an analysis and highlight of all the possibilities and all the issues that has been protracted in the experiment. So which are the next steps? First of all, data collection and gathering from the machine, an economic, social, and environmental evaluation, the definition of the methodologies and the implementation of these methodologies on the architecture of the machine, the implementation of the solution, and then the analysis that we are hoping that reach all the KPIs and objectives that we posed. So thanks for your attention. Oops. Thanks for your attention.
Thank you. Now, touristic platform systems.
Good afternoon, everyone. I am Ciro D'Addio, and I am a co-founder and CEO of TPS. TPS is an innovative small company. Today, I will be talking about the Flight project. Flight is a platform designed to support the research and development of federated learning technologies with a focus on sustainability and efficiency. For researchers, it's a tool that allows for realistic exploration, experimentation, and teaching of federated learning. For companies, it's a reliable testing ground to develop and validate green artificial intelligence solution. We will go through three key points. Why Flight was created, how to platform work, and a real use case, followed by a look of potential future development. The idea behind Flight is to provide an authentic environmental for federated learning. Unlike many simulation, Flight uses real devices to create realistic scenarios. This approach leads to more reliability results, both the researchers and for those developing market-ready solution. The platform will initially support up to 15 clients, each with its hour configuration. It will be possible to test various federated learning setups on multiple datasets, keeping data private on each device, just like in real-world scenarios. Moreover, the devices involved will be heterogeneous, making the simulation ever more realistic. We will use NVIDIA Jetson devices with different hardware specification. This will allow us to replicate typical federated learning challenges, such as performance bottlenecks, limited memory and energy, and communication overhead. These are all crucial issues for large-scale adoption of federated learning. Users will be to choose the dataset and configure the model in detail. The optimizer, loss function, and so. And it is possible for ease change the number of clients, number of rounds, and strategy aggregation. During and after the job, is it possible to monitoring task status? For example, the task is running, is finished, or stop. User will be able to view intermediate metrics, cancel active jobs, and access to interactive dashboard with details results. We'll experiment with classification and prediction tasks using time series data of energy and water consumption, along with weather data and image. This will demonstrate how flight can support different data types and application scenarios. Looking ahead, we are also working on a more customizable experience, allowing users to upload their own dataset and models. New security feature, for example, differential privacy or encryption. And additional optimization and aggregation strategies to improve model efficiency and reliability. Thanks.
Thank you. And now to smart test. We have two parts of this talk. The other one is with Chiara. Okay, you can just.
Okay. So, good afternoon, everybody. I am Stefano Rodino, and today I am here to present, in representative of the company To Smartest, that was founded within the context of FAIR Cascade Call by proposing the SMILE project, that means Smart Materials and Artificial Intelligence for Life Enhancement. Here is a short overview of our company. In particular, our company is a startup spin-off born within the context of University of Calabria, and is supported by multiple international partners like the well-known CERN of Geneva. Our product consists in pipe coupling technology by using smart materials like shape memory alloy, especially in ultra high vacuum application and high pressure application, particular suitable for example, critical environment like the nuclear one. Talking about the SMILE project, our main technical objectives are multiple and are showed in this in the present slide. In particular, the first one and the most important one is the implementation of artificial intelligence algorithms in order to predict the behavior of smart materials, in our case shape memory alloys, that are our main business. And on the second stage, this project aims to develop a robotic solution that integrates smart material for the purpose of the upper limb rehabilitation. In particular, we are at the first stage of our product, that is basically a feasibility study. This is split in two different sections, in particular the analysis of the state of art and the market connected to the upper limb rehabilitation devices in order to understand which is the potential, which are the potential improvements that we can do in this type of device. In particular, some preliminary insights show that these devices are characterized by high cost, large size, and limited portability. And sometimes the high cost doesn't justify the simple features that this type of device have to perform. In the second stage of the feasibility study, we will go through an in-depth understanding of the artificial intelligence algorithms in order to control and predict the behavior of smart materials like shape memory alloys in our case. And this in-depth analysis will bring us to a completely understanding of the integration of these two technologies, the classic robotic device and the shape memory alloys, in order to understand which are the strengths, the weaknesses, and the opportunities and threats in this contest. Here is a short preliminary proof of concept of our device that is basically based on a delta architecture robotic structure, a typical industrial structure for industrial robots. And in particular, this device will integrate the most advanced technology in order to handle artificial intelligence algorithms and a simple controller of the kinematic of the device, like the edge computing represented by NVIDIA Jetson controller. Will integrate also an interactive monitor to enhance the interaction between the patient and the device, but also the professional and the device. And the most important part is the integration of traditional robotic devices with a smart end effector that will be completely handled by shape memory alloys. About the expected results and social impact are clearly shown in this slide. In particular, we would to enhance the home-based rehabilitation by enhancing the patient autonomy. In this manner, it will be possible to completely perform the rehabilitation part of the upper limb in autonomy in a home environment. And in addition, we would also to increase the patient motivation and the engagement by introducing graphical user interface, like, for example, gamification strategies and haptic feedback. By doing this, it will be possible to increase the social inclusion, for example, for people that are affected by neuromotor disability, and by this will translate in improving the quality of life. My expertise is mainly focused on smart materials and mechatronics integration within this project, and so thank you for attention.
Okay, good afternoon. My name is Chiara Morano. Today I will show you some basic results on the activity carried out among the task 9.5.4 about green strategies for robotic design. Okay. As we know, the objective is to reach the 17 goals about a sustainable development. And since our goal is to improve the green approach in a robotic field, we identify two different strategies. On one side, to work on sustainable materials, as defined as recyclable materials, as well as materials obtained from industrial waste recycling, or materials obtained through low energy process. On the other side, another strategy is to realize lightweight structure. In this way, we can reduce the energy consumption and, of course, also the CO2 emissions. By combining these two approaches, we decided to focus on green wearable devices and also lightweight. In this way, we can reach a flexible device. In particular, we realize a very complex structure that is able to adapt to different shape. And this device could be configured in two different shapes in a closed mesh configuration that guarantee a high stiffness and rigidity to the structure. And the other condition is the so-called open mesh configuration, and in this way we obtain high flexibility and adaptability to different shape. Okay, this structure has been evaluated both numerically and experimentally, and we found that it is possible to obtain a very flexible devices and with good mechanical properties. And we also evaluated the maximum bending radius, and we found that it reached up to 6.5 millimeter with a good mechanical response. So we decided to apply this structure for the fabrication of a wearable fixing structure. In fact, the commercially available structure are not so comfortable for the patient. So the idea is to realize a more flexible and more useful wearable structure. And we also integrate this shape with a T-cam that are innovative actuators, and they are both light, and with a silicone that ensure thermal insulation, is also a green materials, and is of course light too. We in this way realize this structure. We try by experimental activity, we realize a prototype for wearable device, and we evaluate the force that it could apply in order to know if this device is applicable for wearable for rehabilitation purpose. And for this reason, we use a force sensor placed in the upper part. Here we have some tests that we did on male and female cavia. And we found that the silicone tape was necessary to avoid slip between the device and the skin. But the T-cam that we choose for the actuation is a good choice, since it guarantees a force that is compatible with the rehabilitation purpose. And the assembly demonstrates a good mechanical precision, and is also ergonomic and comfortable, so it is a good starting point for our purpose. And finally, I also report some very quick other activities. In the same time, we are also working on the strategy for apply thermal direct joining. This technique is green, is fast, and also you offer the possibility to join different kind of materials, and this is our purpose, since we want to introduce green materials and light materials in robotic. But of course, this kind of technique should be improved, and we choose to use the laser treatment. And in particular, we analyze different combination of laser parameter in order to improve roughness. We evaluate the results through mechanical test, and we found that this laser treatment, at the end, able to improve significantly the toughness of the joint. These activities, we are carrying out this activity in cooperation with ISC 9.6.2. And the final aim is to apply AI-based algorithms to optimize laser parameters to obtain the best surface configuration. Okay, thank you for your attention.
Thank you, Chiara. And now, NR to crowd.
Good afternoon, everyone. My name is Nicolò. First of all, thank you for the opportunity, and I'm here to show you our project about the green artificial intelligence training with the acronyms of GAIT. First of all, a short bio about myself. I'm a nuclear and energy engineer, graduated at the University of Pavia, and then at the Polytechnic of Turin. And I co-founded with other people, with other founders, a company named NR2Crowd, which owns also a second company named Catudi. Basically, NR2Crowd is the leader in the Italian market for the alternative finance, and we are a group of engineers and people with the expertise in the energy field. And also with Catudi, we created a company which basically work in the carbon credit voluntary market, and we created our own protocol, and we also have an expertise in the artificial intelligence. We divided this kind of project in 8 different work packages because we perfectly know that the biggest problem with the artificial intelligence is the energy consumption for the retraining of the artificial intelligence itself. So our goal is to find out a solution and a system that will be able to reduce the energy consumption and to optimize the energy consumption, in particular for the retraining of an artificial intelligence. We divided and we split the job into 3 different layers. The first layer is about the algorithm of the artificial intelligence that we will not touch because we want that our solution will fit with all the artificial intelligence in the market. The second one is the frequency of the retrain of the artificial intelligence, and of course we will work on it because we want to find out what is the best moment to retrain the artificial intelligence, because most of the companies usually do the retrain of artificial intelligence not in a specific moment, but when it is needed, and most of the time the moment is not the right one. And the third layer is of course about the quality of the data, and we will work on it in order to study how to give a higher quality of data in order to retrain the AI with a lower energy consumption. Of course, in order to do that, our goal is also to define the KPIs to find out how to reduce and how to measure, because the biggest problem here is to measure the energy efficiency consumption and the reduction of the retrain of the artificial intelligence. And in the work package 3, I think that it's the most difficult one. We will try to define at the baseline and the KPIs of our project. Then we also have to work in 2 different case studies. We selected 2 relevant companies with an AI, and we will test our solution with these 2 different case studies. The last thing to do that we will do in our project will be about the prototype, because we will implement a platform which integrate this green retrain framework in order to provide retraining recommendations. So the goal is to say, okay, this is the moment to retrain the artificial intelligence in order to reduce the energy consumption. The goals, of course, are 5. We have 5 different goals. So the first goal is to create, of course, a decision-making framework to optimize the retraining of the AI. Then to develop the platform itself, and also do a regulatory analysis and certification, because our goal, our study will also deeply go into the definition of the carbon credits, because ideally we want to define, also give the structure of a first certification protocol for this kind of energy reduction in order to create the carbon credits. And we also will disseminate this kind of project with the webinars and with the workshops. I think that it's missing the last one. Thank you so much.
Thank you. Now, DigiTwin.
Hello everyone. First of all, I'm sorry for the presentation, which is written in Italian. I'll try to be clear beside of this aspect. So, I'm Luigi Esposito, and today I present to you RACE, which is a project proposed by DigiTwin within the Spoke 9 of FAIR. DigiTwin is an innovative startup spin-off of the CNR, which develops a solution of environmental intelligence, so solution based on digital twin to achieve greater sustainability in the social, environmental, and economical aspect. RACE stands for Real-Time Eye-Driven Yield Optimization in Agrivoltaic System. So in accordance with the Objective 5 of the Spoke 9, we will develop a digital technology for the design, monitoring, and control of agrivoltaic system. So using digital twin technology and AI algorithm, we will be able to define the optimized configuration in real time in terms of agricultural yield and energy production without any waste of natural resources. So the project is divided in 3 work packages. Within the first work package, we are developing the dynamic model of the photovoltaic system, and we are investigating the influence of the shading on different crops. Within the second work package, we are conducting a technical economic feasibility study, and sorry, this is the work package 3. So I was saying in work package 2, we are defining the digital infrastructure for the control and the monitor of the system, and we are building a scale demonstrator. In work package 3, as I was saying, we are conducting a technical economical feasibility study and a multi-objective optimization using a genetic algorithm. I missed one thing, sorry. The team which is taking part of the activity of the project is composed by Michela Costa, who is the principal contact of the project, myself, and Davide Sgambato. Myself for the design of the scale demonstrator, Davide Sgambato with his thesis, master thesis for is developing the different models. Talking about models, we considered every aspect of the process. For example, starting from the model of agricultural yield, we are able to calculate the direct and diffuse shading factor, and with them evaluate the direct radiation reduction. With this quantity, we can enter the graph here in the slide, and based on the different type of crop, we can evaluate the reduction of agricultural yield. For the model of the PV, photovoltaic system, we are able to evaluate the power generated by the PV depending on the total radiation, considering also a correcting factor based on the temperature of exercise. For the shading model, we are able to obviously evaluate the shading depending on the inclination of the sun and the PV. And lastly, with the sun path model, we are able to evaluate the total radiation and the two shading factors used in the previous model. Within the work package 2, we are designing and realizing a scaling demonstrator in a rooftop configuration, as you can see in the picture 1. Picture 2 shows you what we have designed. So we will have 3 configurations, one totally shaded, one with no shading, and one partially shaded to watch the differences between the 3 configurations. In the picture 3, you can see the work in progress. The system will be managed by a series of sensors connected via IoT. For the as application for our model, we selected a farmhouse situated in Potenza, which characteristics are reported here in the table, for which we individuated 2 operating profile, one for the summer and one for the winter. The picture shows highlights you the area dedicated to the installation of the system, and here in the table are reported the crop cycle. Based on this case study, we conducted a bio-objective optimization in terms of agricultural yield and energy production, varying different variables such as minimal heights, inclination, area, and interline of the panels. The optimal solution is the green one in the Pareto front, which is characterized by an energy produced of almost 400 megawatt per hour for year, with a reduction of agricultural yield of 7%. But I want to highlight to you the variation of agricultural yield of the tomato, which is plus 30%. From an economical point of view, considering the initial investment and the revenues, we have a simple payback of 7 years, which is reduced to less than 3 years, considering incentives from the legislation. So to wrap up, we did some advanced models. We developed some models, so for the PV, for the influence of the shading on the crop, technical economical feasibility study, and multi-objective optimization. Next step will be to improve our models, integrating a model for a PV, solar tracking PV, and the models for the crop growth. Then, when our scale demonstrator will be ready, we will conduct an experimental campaign to validate our model. We are interested in integrate some AI algorithm in our models to reduce the computational effort, because right now we are with a computational time of 5 hours and 1,200 operating condition investigated. So in order to do this operation, this simulation in real time, we need to reduce them. Thank you all.
Thank you. And now, Kairos.
Good afternoon, everybody. I am Luca Sabbioni from Kairos, and what I'm talking about today is the project Solaris, Solar Optimization and Lifecycle Automated Robust Integration Systems. Here we want to study all the life cycle of solar panels, from its design to its maintenance. So mainly we want to develop an AI power system for the design, monitoring, and optimization of photovoltaic installations. So we have 3 different modules, and each module will be addressed with different kind of AI techniques. The first one is a solar panel layout automatic generation. So we want to start from the GPS coordinates where we want to design the solar panels, and we are retrieving the orthophotos, so the photos from Google Maps or Solar APIs, to retrieve the mapping. Moreover, Solar API, still from Google, provides also the DMS, which is a color map of the altitude of the roofs. In this way, we can use image segmentation tools to identify the roof structures and all the slopes, which are le falde in Italian. So we can identify also which are the obstacles and the main points, shaded points from the roof. And using gradient analysis on the color map on the DSMs, we can also identify which is the orientation of the slopes. In this way, we can provide also integer linear programming to identify which is the best composition of the solar panels on the roofs. This is the main module we are working on right now. And the next ones are completely different and are, for example, the module 2 is devoted to the maintenance of solar panels. So here, the idea is to make fault detection and diagnosis for these panels. Indeed, we have access to real-time monitoring of the voltage and the current created by the panels, and also the solar irradiance in photovoltaic systems. So we want to monitor which is the main gap between the optimal conditions of the solar panels and the energy which is effectively produced. So we are, the idea here is to train some supervised learning systems, neural network or decision-based models, to make accurate voltage prediction so we can, in the best conditions, so that knowing the solar irradiation, we know in the best conditions which is the expected solar power generated. And from this we can make some anomaly detection systems to understand if there is any fault happening right now. Moreover, the faults can be of different natures. They can be abrupt if there is something broken for different reasons, but they can also be smooth because of deterioration of like dirt getting on the panels and other reasons. So we want to also understand which is the main reason of this fault. So we are the idea is here to use support vector machines to make fault classification and diagnose the failures. This is useful because the different faults leads to different kind of instruments and like workers needed to repair the faults. The final module instead is completely different and is the optimization of batteries. Indeed, of course, the best situation as possible is not to provide always the power to the power grids and retrieve the energy needed from the power grids, but to store them in the batteries. But their life cycle is limited, and every time we make a cycle of charge and discharge, a little bit of capacity is lost. So we want to make an optimization system for energy flow management using reinforcement learning. So we want to take into account the costs of getting energy from the power grids and the small gain we have whenever we decide to give our produced energy to the power grids, and some kind of equivalent costs for making a charge and discharge cycle for the within the batteries. So we want to study this trade-off between the economic savings from battery usage with the long-term degradation costs of the batteries. So in this Markov decision process formulation, we want to select at each time, depending also from on the solar irradiation, the best fraction of power to give to the batteries or to the power grids, and on the opposite, whenever I have an energy need, where to get the energy from, still from the batteries or from the power grids. So the main goal here is to reduce the financial losses and enhancing the total independence of energy, and to improve also the usage of the whole life cycle batteries. So thanks for your attention.
Thank you. And now VT Solutions and Consulting.
Hi everyone, I'm Sara Foresta, and I'm part of the research and development and product team at VT Solutions. Today I'm here to present the Human Game, an initiative that combines innovation in HR management with artificial intelligence technologies and gamification techniques. VT Solutions is the company behind this project. We operate in the professional services sector, offering custom solutions powered by AI-based process automation. Over the past few years, VT Solutions has taken part in events like AI Week, the Databricks AI World Tour, Azure Day, and Asana, sharing knowledge and best practices. The goal of this project is to help tackle a challenge that many companies face today: managing skills and reducing employee turnover. Turnover leads to serious consequences: loss of key skills, project delays, and a general sense of uncertainty within the teams. Companies need to protect their know-how and ensure operational continuity. To do this, they need a targeted HR strategy focused on talent retention. That means investing in developing existing skills through upskilling and reskilling. Upskilling helps employees adapt new market needs, while reskilling prepares them for new roles better suited to their potential. A Human Game was born from the idea of using an hybrid approach, AI and gamification, to more accurately identify skill gaps. So, the approach. Human Game is structured into 5 main phases. First of all, we study complex HR processes and global taxonomies to align internal skills evaluation with international standards. We also benchmark existing AI technologies and apply it to HR. Then, AI and gamification for skills. So this activity explores AI models, especially NLP and machine learning, to analyze unstructured data like CVs, project documents, and tenders. We also research gamification techniques to detect both hard and soft skills through realistic simulations, capturing hidden skills that often don't show up in formal documents. So, we define methods to identify skills, develop gamification strategies to assess soft skills, and create AI models for optimal resource allocation. Here, we move into building the actual models designed in phase C. So we prototype algorithms for team composition and develop models to match skills with the training needs. At the end, we test everything in real company environment, so compare skills, identify through AI and gamification, and integrate the results. So, about the general goals, the project aims to accurately map existing skills by integrating internal data with standardized external sources, like the ESCO and ISCO dictionaries. This results in a corporate database of employee skills and experience with scores based on the competence levels. Quickly identify skill gaps and training needs and guide the creation of tailored upskilling and reskilling plans. And it optimizes resource allocation but align people to projects that match their skills, experience, and interests, while also considering internal business needs and external opportunities. So, expected impact. Human Game is fully aligned with the objectives of the Future Artificial Intelligence Program, SPOC 9. The expected benefits include lower turnover cost and more effective management of human capital, better visibility and use of internal skills supporting sustainable growth and smart management, promotion of continuous learning, an advanced AI framework for skill extraction and analysis can support the evaluation of AI-driven HR methods, tech transfer and outreach, so through events, workshops, and academic publications, and partnership with researchers and businesses. So, thank you for your attention.
Thank you. Now, informatica.
Okay, so good afternoon. I am Davide Scintu, and I am the hardware engineer of the Informatica. The Informatica was born in Matera, and since 2014 we are on the side of the societies that believe in the innovation. So we try to help people to develop new projects and to try to believe in their dreams, building their projects. We have 23 invention projects and 5 for the utility model. And on the right are the team we are focused on. On the left, you can find some picture about some rewards that we reached on the last 2 years. The Top of the PID and the Sole 24 Ore, il Vaticano from the Sustainability Society. On the base of our society, there are human factors and also high specialization. So we focus on software development, hardware development, firmware, 3D modeling, concept design, and so on. On the right, you can find some of our products, such as Real Verso Lucanum, and Robocom Inclusion, and the Brain Friend. With regard to the accessibility digital solution, our product, Robocom Inclusion, is based on sound and vibrations in order to show images, complex images, guided from a voice. So with an haptic feedback, we are able to show and make available a complex image, also for people who have some disability. From the state of the art, some of the main technologies for people who are blind are Navilence and air-feed technology. Navilence utilizes the codes that you can scan with a specific application, while RFID are integrated in some floors or something like that. And it's possible to understand the content of these tags with intelligent tools. Both the technologies, for sure, are able to help blind people, but needs to invest in some infrastructure, for example, like Logos Vet. There are also alternatives, for example, the beacon BL solutions to the substitution of the RFID, but also there are applications for smartphone, such as Microsoft Seeing AI and Google Lookout, that are based on computer vision. Our solution, so Visual Impaired Hat, is an embedded system. So with a simple hat, we are able to help the user in order to find a specific path using advanced sensors, computer vision, and AI modules. With respect to the technologies I mentioned in the state of the art, this system is embedded in a single element, so the hat. Thanks to the acquisition of the scenes and also with the computer vision, basically, and also with the use of smart tags such as beacon, the user is supported in the orientation along a specific path without the necessity to work on a specific floor. So the system not only is able to catch the obstacles, but also to describe the scene and also to personalize the representation of the scene with an haptic feedback. So artificial intelligence modules are able to describe the scene, and the storytelling is adapted in the with respect to the user, such as the age or other different abilities. And so with an embedded system, we are able to pass over the limits of the actual technologies. So the project is composed in three phases. So the first one is the industrial research. So with the study and the definition of the methods and the acquisition, and also the interpretation, AI-oriented. Then the experimental develop, so the prototypation, basically, and then the study of the factibility. Also, we are able to improve our product, our prototype, thanks to a focus group with the collaboration with the blind union in Potenza and Cagliari. So the objective of the project are the first one, the project and the prototypation of a hat with advanced sensors, smart tag, and computer vision modules. So we are able to identify the scene. The second one is to project and prototype an AI system able to translate and also give a feedback in real time, for example, with a smartphone. And for example, we are also able to analyze an art picture. And so with a personalized storytelling, as we said, with regard to the age and different abilities, we can improve also with this ability. And the third is the evaluation of the factibility, and so we can analyze the compliance, the interoperability, the scalability, and the impact to the ambient, and so we can improve that in the long time. Thank you for your attention, and here are my contacts.
Thank you. And now we have online the pitch from True Sense.
Buongiorno Francesco, everybody. Mi sentite?
Yes.
Okay. Good morning, everybody. Good afternoon. Sorry for not being here. I could not participate today, but I'm very honored to be with you all. So I share my screen. Can you see my screen?
Yes.
Okay, so we start from the technology we use. ToolSense is a company expert in ultra-wideband sensing. Ultra-wideband make it very easy to be applied in many use cases because of accuracy of location, of secure ranging, and radar sensing. We are partner of NXP Semiconductor, among the others, and this particular project is based on NXP technology. There are two ways to use ultra-wideband radar. It's very innovative and ranging. Ultra-wideband, we use it in this particular project in both ways. Ranging is when the point-to-point can detect each other with very precise distance and high accuracy. So it means that plus or minus 7 centimeters, I know where one target is to the other. A radar is in presence of no wearables, so it's just radar pulse sensing, where we can detect movement and obstacle without having another device on the other side. But the most interesting thing is that there are billions of mobile phones from Apple 11 onwards, Samsung 20 Ultra onwards, Pixel 6, Oppo, Xiaomi, that already have deployed with ultra-wideband. And thanks to this, ultra-wideband can be enabled automatically in the smart apps. So when we are in front of UWB, the smart apps are actually running and working in the background to make things happen. As a ToolSense, we follow the consortium, like the Carnot Connectivity, FIRA, with the FIRA Consortium for regulating anything in the world that connects to one point to another and radar sensing. And we have different solutions. However, everything we do, as I said, makes the things by magic. Now I'm going to show a short video that can describe different use cases from radar sensing to ranging. So leveraging all the automatism that UWB can enable, we have figured out a project that we call AI Guide. From the name, it's clear that we can provide from impaired visual people an aid to two things. One is avoiding collision, so rapid alerts when there is a problem, when going somewhere, when there is a dangerous situation in the surrounding environment. And the other one is even guide them when indoor and outdoor sensing is transmitting data. So if I am in front of a railway station, I can tell the person turn left, walk 3 meters or 3 steps, go right, and so on to find the rail number 5 or whatever track. Now this is in line with the objective 7 of the program for high-impact AI application in the sectors. So the two technologies we're going to use are real-time location system for indoor and outdoor areas, and the radar sensing for anti-collision, as well as sensing the environment where other sensors are not. Now, in this respect, we would like and we target to move the experience of going almost, I would say, don't know where I'm going, maybe the train is there, maybe it's not there, maybe there is an obstacle, maybe I need to turn right, left, up to going into, I would say, an FP, almost a inspired person working with the introduction and guides. Now, for us, as I mentioned at the beginning, open standards are extremely important. We will align to a wayfinder who is an audio standard who can help already standardizing the standard navigation in the phones. And of course, there will be a lot of synergies with the package and the project shown earlier. So probably some synergies in there, but I think it's going to be extremely of impact to the life of people. And that's what we love about this project. And thank you, Francesco, and the University of Calabria for making this happen. I am done.
Thank you, Armando. So we close this session and we start the session with posters, and then we will have the coffee break in the same place, and then we will restart again at 4:30. So now let's go to the poster.
Thank you.
Abbiamo una borraccia qui? Qualcuno ha lasciato la borraccia? Di qualcuno e ricominciamo. Let's start the next session on Green AI. Di Fabrizio? So Riccardo Cantini, Luigi Pontieri, Carlo Morabito e Mario Cannataro can join us here so we can go faster. And the first speaker is the chair, Professor Domenico Taglia.
Good afternoon. So we go to start the session on Green AI. This is a session of WP 9.3. I will just introduce the main topics of this work package, of this session. So we aim to investigate machine learning and AI algorithms. In particular, algorithms that are able to deal with limited amounts of data and reduced computing resources for learning tasks, obviously. So the goal we want to reach is reached by exploiting available domain knowledge, energy awareness. So the energy awareness is one of the important features that we want to include in the learning algorithm that we use, and obviously on the estimation of devices or computers, energy consumption. So we explore the combination of symbolic and sub-symbolic approaches in solving problems, in particular where we need to save hardware and software resources and energy. So these are the main 5 objectives that obviously are related to what I mentioned before. So developing machine learning solution for energy efficient data intensive AI, designing energy aware machine learning techniques, exploiting informed machine learning for green AI, designing green deep learning for clinical AI, and exploiting machine learning techniques for bioinformatics in particular. These 2 final objectives are the objective of the Cascade call, and colleagues from University of Reggio Calabria Mediterranea and from University of Catanzaro Magna Grecia will discuss about that. So these are the main 4 tasks of this work package. And as I mentioned before, while the first 2 tasks involve people, researcher colleagues from University of Calabria and from CNR, the third and the fourth task are carried out by colleagues from Reggio Calabria and Catanzaro, from University of Reggio and University of Catanzaro. So this is the list of contribution today. So the first speaker is Riccardo Cantini from Unical, and is going to speak about towards interpretable energy estimation for edge AI application. Please, Riccardo, come. You need to manage to close this and to find it. No, there is a window with your... okay, you can close this. Okay, you have here. Okay.
Ok, sì, un po' sì.
No, così.
No, a posto. Ok, pensavo andassero. Grazie. Okay, so good morning to everyone. I am Riccardo Cantini, as Professor Taglia announced. And today I will talk about our activity titled Towards Interpretable Energy Estimation for Edge AI Applications, a work did in collaboration with Professor Taglia, Professor Trunfio, and Dr. Orsino. So before starting with the discussion about this work, I wanted to give you an introduction to the main concepts and goals of the task 1 of the work page 3 of the SPOC 9, and also the main research lines about these kind of activities. So we are addressing sustainability from different viewpoints, mainly the two listed in the slide. So from an environmental point of view and the social viewpoint. So for what concerns the first one, environmental sustainability is addressed by optimizing energy usage and resource management in machine learning and AI workloads. So we want to design basically green-aware solution to facilitate harnessing the capabilities of AI systems at the edge of the network. For what concerns social sustainability, from the other hand, we want to promote inclusivity and fairness in AI systems, basically by uncovering and mitigate biases that can emerge from the use of these systems, both from general purpose systems and fine-tuned systems in critical domains. These are the main research activities related to these research lines. So for environmental sustainability, we are currently focusing on interpretable energy estimation for AGI application. That is the topic on which this presentation will focus. And also other activities like cross-architecture knowledge distillation of large language models to exploit this kind of models, all the power of these models at the edge of network, so on resource-constrained devices. And also efficient test-time adaptation on edge device. So how to adapt models efficiently deployed on resource-constrained devices. For what concerns social sustainability, we are addressing this problem by looking at the bias that can emerge from the usage in the response of large language models deployed in a diverse range of settings, from general purpose models to models deployed in specific settings like clinical or medical large language models. Basically, finding biases through a jailbreak analysis, so testing their adversarial robustness to bias elicitation. So talking about Edge AI, this is the main topic of today, what are the key advantages and challenges of Edge AI? First of all, Edge AI refers to AI and machine learning models that are executed directly on edge devices instead of centralized cloud machines. So we want to push the intelligence to the boundary of the network. And these are a huge range of advantages, ranging from reduced latency, optimized bandwidth usage, and privacy preservation. So we can do, for example, near real-time or real-time decision making, and we can ensure privacy in critical settings, like, again, the medical domain. But all these advantages, of course, comes with challenges. For example, the limited computational resources we have on this kind of devices, like CPU memory storage, energy constraints, because these devices are alimented by batteries, so they are battery powered, and also the complexity of the methodology available today for estimating the energy consumption of machine learning workloads executed in these settings that basically lacks interpretability and granularity. And this is the point we want to address with the research I will present today. So our research objective is to develop an interpretable energy estimation model that provides both an accurate energy consumption prediction for an edge AI workload, and also a fine-grained and actionable insight of this consumption estimate. This has a very wide range of application and a huge impact on Edge AI because it can support the adoption of green-aware strategies in a wide range of applications, like, for example, green-aware neural architecture search or the development or informed green-aware schedulers in edge settings. And also this kind of interpretability that our methodology provides can allow developer and engineers to optimize the workload they want to deploy on the edge cluster or in a distributed setting, because we can give them an estimate of the energy consumption and also an interpretation that we can use and which is actionable, so they can use it to effectively improve the workload that they want to deploy at the edge of the network. So this is our problem formulation. So we have the energy consumed by an algorithm A executed on a dataset D within a fixed distributed architecture, that is an edge-based architecture in this case. And we can decompose this consumption as the sum of 3 factors. So the consumption related to the computation, the factor related to data access, and the factor related to communication. So we have these 3 factors. Their sum gives us the overall consumption. We frame the interpretable energy estimation problem as a 2-step process. Firstly, we want to estimate each of these 3 energy components by unveiling the pattern that link each of them with algorithm characteristics and data characteristics. Then, we want to use explainable AI techniques to provide insightful interpretation of these consumption estimates to the user. So, for what concerns the first one, we want to model energy factors by using learnable proxies. So we can represent a given pair algorithm dataset with a feature vector, we call this F, that describes algorithm dataset characteristics. So by using this, we can rewrite the energy consumption by writing each factor as the multiplication between a proxy. For example, we have a proxy that is a measurable counter that we want to explain in the next step. That is the result of a regression model applied to the feature vector. And then we have these beta factors shown in the formula that can convert these proxies into actual energy values that is measured in joules. The next step, so the second one, is to interpret the energy estimates by using explainable AI techniques. So we want to unveil the different relationships that links the input feature F with the total energy consumption. But since the overall consumption depends on the different proxies, we can reframe this problem as the explanation of the prediction of the different regressors R on F that basically gives us the proxy for that factor. So we have different factor, computation, data access, and communication, and we can explain the prediction of the regressors that can generate these measurable counters. And this can give us basically an explanation that is fine-grained and component level. Because, for example, we have the feature level explanation for that specific contribution to the consumption, for example, related to communication or data access or communication. So this approach can give us the number that is the overall energy consumption and also an actionable estimate that the user can exploit, can leverage to optimize the workload that he wants to deploy at the edge of the network. So this is the proposed methodology. We have basically 2 steps that are the box showed in the left side of the slide. We have the training of the machine learning models and the user query response generation. So in the first step, training of the machine learning models, we collect training data by executing a series of pairs algorithm datasets and collecting the value of these proxies. There are measurable counters like execution time, cache misses, and so on, by creating in this way a dataset of executions. Then, by using this dataset of execution, we train a set of platform-specific regression models that can predict the value of that specific proxy. So basically, we have a regression model for each proxy. And we have also a classifier C that filters out all that execution that are unfeasible. For example, execution that would violate a set of user-defined constraints, like execution that go for a time that is greater than a fixed threshold, or, for example, exceeds the maximum available memory. So they would result in an out-of-memory error if executed. The second step, user query response generation, works as follows. So first thing, the classifier evaluates whether the pair algorithm data, so the execution is feasible, that is, respect a set of constraints indicated by letter Q in the slide. So if constraints are violated, the application is rejected by the system, and an explanation of this non-executability is provided to the final user. If Q equals 1, so the application is accepted, it proceeds with the following steps. There are for the regression of the proxy and the computation of the overall energy estimate. Okay. These are our experimental setting. So our experiments were carried out on the Raspberry Pi 4 Model B that featured a 64-bit quad-core Cortex-A72. Also, we used the scikit-learn implementation of the machine learning algorithms listed in the slide, ranging from decision tree, k-means, to the principal component analysis and linear regression and so on. And also we used perf as a profiling tool to measure these proxies, so measurable counters, and RS Pro digital multimeter to the actual measurement of the energy consumption for testing purposes, to compare this estimate with the real energy consumption. So the experiment I will show in this slide are preliminary results that we generated to provide an initial assessment of the effectiveness of our methodology. So these results were achieved in a single device setting, okay? So no data exchange occurs between devices. So in this case, we removed the proxy related to communication. And we tested with computation and data access proxies in these results. So for what concerns the design of experiment, there is an important step because we want to generate a data set of execution on which train the models that can predict the proxy values. So we want a balanced and statistically significant data set. And for this purpose, we used the hypercube sampling, the OLHS methodology. That is a statistical sampling method designed to create evenly distributed sample in a multidimensional space. The final training dataset D that is obtained is a dataset of execution. So we run all this execution by monitoring by using perf, the profiling tool, the value of the proxies. So we create the dataset to be used to train the platform-specific models to predict the proxies. We used the two proxies listed in the slide. So the execution time for computation, because it reflects how long the application runs, with the scaling factor is the device's average power consumption at full CPU load. And for what concerns memory, we use the cache miss because it indicates instances where data must be fetched from slower memories. So indicated a huge access to the main memory and also, for example, an inefficient memory access layout of the algorithm. So cache inefficiency in this case. So those listed in the slides are the classification regression results. So how accurate are our platform-specific regressor and the classifier to filter non-executable applications? We tested them with two sets of constraints. In both sets of constraints, the memory is set to the maximum available memory on our Raspberry Pi. This is 4 gigabytes. And we tested with two thresholds for execution time. In all tested configurations for both tasks, the Autodub PFN model outperformed the competing models, both for regression and classification. This is a pre-trained transformer model that is optimized for in-context learning of small tabular datasets. So it's very general and it's very robust for this kind of small data classification and regression tasks. So now I will present 3 test cases that are end-to-end instances provided to the systems with the related prediction and explanation with the interpretation for the final user. So for what concerns test case 1, we tested the algorithm logistic regression with a dataset of size 501 megabytes and the number of rows and columns listed in the slide. The classifier prediction was out of memory error. So the classifier correctly predicts this execution as non-executable and correctly predicts it as an out-of-memory error. So it exceeds the maximum amount of memory available on the Raspberry Pi. This is 4 gigabytes. As the application is rejected because the classifier filters out it, we provide to the user an explanation of why this application is non-executable by using the absolute values of normalized SHAP values. In the slide, for all the features, taking into account in the explanation, the absolute SHAP value normalized is shown with also an arrow. An up arrow is a feature that positively contributes to the prediction. A down arrow is a feature that negatively contributes to the prediction. So in this case, for example, dataset size is the most important feature that contributes positively to the prediction. So an interpretation that the user can gain from this is that the high dataset size led to excessive memory use, causing an out-of-memory error, for example. This is test case 2. We have an SVM, state vector machine algorithm, run on a dataset of size almost 245 megabytes with the number of rows and columns listed in the slide. So we have a huge number of rows here. The classifier correctly predicts it as non-executable, so with a timeout error. This is the explanation of the non-executability, in this case provided by normalized absolute shape values. So in this case, the number of rows is the most important feature contributing positively to the prediction. So an interpretation could be that the SVM model struggled with large row sizes, leading to an execution timeout. This is the last one. So a random forest executed on a small sized dataset with the number of rows and columns, again, listed in the slide. The classifier predicts it correctly as an executable application. So it fits with the set of constraints that we imposed to the system. And so the application goes ahead for the energy consumption estimate and interpretation. So we have the two regressors, one for each proxy, that predicts execution time and cache misses. In both cases, the algorithm is the most important feature that helped the model to correctly predict execution time and cache misses. So an interpretation that the user can gain is that while the execution was successful, cache efficiency optimizations could reduce energy usage further, because, for example, we have a relatively huge number of cache misses, and the algorithm is the principal responsible for this value predicted by the algorithm. Of course, by combining execution time and cache misses with the respective beta factors, we can get the energy values, and by summing them up, we can get the overall energy consumption that in this case, for example, was about 1.2 kilojoules. That is very, very near to the actual value we measured with the multimeter. So, by concluding, the main contribution of this work are as follows. So, a novel methodology for interpretable energy estimation in edge AI settings. This is the first approach that combines explainable AI with an in-context learning-based energy estimation in an edge AI setting. It can support green-aware practices in many ways by providing fine-grained interpretable energy estimations to the user. And it has a huge impact and also a wide range of future applications, like optimizing AI deployment in low-power edge environments like the Internet of Things, mobile AI, and so on, enabling real-time energy-aware decision-making at the edge of the network by reducing latency and optimizing bandwidth, and also supporting green-aware AI applications at large, for example, like green-aware neuroarchitecture search or machine learning workflow scheduling optimization. So, by concluding, this work was accepted for publication at the Intel for AC workshop that will be held in conjunction with the EPDPS 25 conference. And that's it. Thank you for your attention.
Thank you. Thank you, Riccardo. Any question? Please. I don't know if you must come here or we will bring the microphone.
No.
In slide number 10 or something like that,
okay.
You had a table about, yes, here.
These? Okay.
Yeah, the times are in second, and what I see, 39 plus minus 10 seconds.
Mm-hmm.
Is it logical for have these kind of variances in the time? So
What?
the number of iterations that you performed, is
This
it
is
logical to have these kind of variances?
This is average on 10 runs.
So is it logical? Because as far as I see, the variances are very high. You know, this is my question.
Yeah, because you are executing application on a constrained device. So on a Raspberry Pi, you have several factors that can influence execution time. Like, for example, when you execute these 10 runs, for how long the device is running, you can have small differences, for example, for an increase of the temperature of the device that can change, for example, the inner working of the device a little. and also non-determinism for all the measures we did.
So doesn't affect also the energy consumption? This internal behavior changes also changes the energy consumption. So how the estimates doesn't change?
It can affect the final results. For example, in the last row, the variance is compared to the actual mean in difference smaller than that. So we have this kind of problem, let's say, in application that lasts a little time. But this is somehow normal in a sense, okay, because time is non-deterministic. So you have not all the executions with the exact same time, no? Because this depends also for the convergence of the algorithm and all the inner working of the device. Okay, you're welcome.
Thank you. So let's thank again. And we can move to the next speaker. The next speaker is Luigi Pontieri. Luigi will speak about activity at ICAR Senar. The title of its contribution is Data Compute Efficient Machine Learning from Green AI.
Hello everyone. I am afraid I prepared too many slides and I cannot be as fast as Riccardo. There is no way to me to do. So I will present at half the way, tell me. So I will cut something. Okay. Yeah. This is the title, but already has been said. Yeah, too high for me. So, I would like to give you a helicopter view to the variety of topics that we tried to pursue in this project with my colleagues, and many topics maybe, but they concentrate along two main directions. The first one, two research questions. The first one is, can we use smaller data and models and faster training schemes, acceleration, without worsening the results, the quality of machine learning methods? So Green AI is for us mainly machine learning, data-driven AI. And which model architecture, how we can change the training procedure, and so on. And the second main research question is, can we use prior knowledge in order to spare energy, time, consumption, and resources, and make machine learning greener? Yeah, clearly, in both directions, we also tried to give an eye to interpretability of models and results, and to the usability and reusability of models and results. And just a definition, just a sort of definition. Which kind of knowledge have we considered in the project? Two kinds of knowledge mainly. Implicit knowledge, tacit knowledge, embedded in some sub-symbolic model or language model maybe, and pre-trained black box models, or knowledge, tacit knowledge possessed by experts, by humans. The second kind of knowledge is declarative knowledge, symbolic knowledge, in the spirit of neural symbolic or neurosymbolic approaches. Yeah, these are the three sublines for the first research question. First research question, let's put away the problem of knowledge, and how can we make machine learning more efficient, more data efficient, and more compute efficient and energy efficient. We tried to define techniques for synergistic data pruning, data reduction, and training. So while training, we want to reduce the amount of data. And we used some kind of data selection methods inspired to learning. And the second one is let's compress the data. And which kind of data? We focused on graph data or network data that can be very big. And the main kind of compression has been for us sparsification. We defined some techniques in this field. And the last kind of solution that we explored is to condensate data into a model, into a probabilistic model, into a generative model, but not a language model to core, but a generative model for some kind of data. In particular, we focused on the case of discrete categorical sequences and consider the case of process trace generation or completion. And we used as a generative model, a conditional VAE model that is interpreted in some way because it provides an explicit likelihood distribution. And these are some works that we published on intelligent and adaptive data selection while training or with an eye to the task, to the final task, to the machine learning task, and some work on more classical active learning or semi-supervised learning approaches to the case of learning with small data, with small, few labels through an interaction with the user or so on. The second direction, knowledge-enhanced machine learning. Which research lines did we pursue? The first one was to take the knowledge from user and pre-trained models by fine-tuning, for example, pre-trained models, language models, but small size. And the second line is to try to propose some kind of compositional approach to machine learning, to AI, data-driven AI, a modular approach. For example, we explored some multitask or ensemble learning techniques, and a special kind of ensemble, the mixture of experts, that is, I will present afterwards, maybe, and neurosymbolic framework. So pre-trained model can be used as a source of knowledge. We can use a small-sided encoder only model as a feature extractor or representation, a pre-trained feature extractor. This is a classical more or less. And also we can exploit the generative model for information extraction. For example, it is very popular in the industry. And the last task that it is an ongoing work, is to try to align a pre-trained generative model, instruction-oriented generative model, like a chatbot, in an efficient way by using efficient data selection and sampling techniques. Compositional approach to machine learning and AI. We can decompose a big problem in several tasks. And so we can decompose the model and the system in sub-models and subsystems for each of these tasks. One of these models, sub-models can be heterogeneous. They can be, for example, a neural model and a symbolic model. And this is the case of the approach that we developed with the colleagues from task 941, that we combined the symbolic reasoner, abstract argumentation based, with a neural network sequence tagger in order to interpret low-level traces, low-level event sequence, categorical event sequence in terms of high-level activities. That is important in cognitive systems, for example. So the other kind of approach that we developed with some colleagues from DMS in the group of Professor Talia, it is LM-empowered machine learning workflow. We want to compose different kinds of agents based on LM and other techniques, maybe symbolic techniques, symbolic methods. In this case, we come back again to the problem of having a small number of labeled data or known. So we want to have an expert to label a small amount of these data. The vast majority is unlabeled. So we have a labeled data set. Okay, the pointer, where is the pointer? Okay. Labeled subsets and unlabeled subsets, and we want to use pre-trained language models but small sized, BERT-like, that were fine-tuned on natural language entailment tasks. So they can be used as a sort of zero-shot classifiers, but they are not so effective. And so we don't want to use this as a final classifier, but only as a sort of annotator. And we use an ensemble of such classifier or such weak annotators, and with uncertainty-oriented and ensemble-based techniques, we want to filter out the most reliable labels and train a small language model, a decoder only, a BERT model that is MEL, compared to current one. And the results are very, very interesting. Other kinds of approach to informed machine learning, we want to inject we are trying to inject constraint into the training loss as a sort of semantic regularization. It is a classical approach, and we are not sure that it is will actually allows us to spare energy and time, because we have to optimize two losses simultaneously, so we can have longer convergence time. And we want to extend other lines, but we have no result on this. And the other idea is to use modular and sparse neural network architecture as an enabler for efficient and informed machine learning. Modular models can allow us to inject knowledge, but reusing existing models as subparts, as submodels. But modularity is not enough for efficiency. So we want also the model to be sparse, because we don't want to have a big model. We can use knowledge distillation, operator factorization, quantization, but we also want sparsity at runtime. And this is where mixture of X's come to play, because mixture of X's are the basis of all modern language models, large language models. It is what is a mixture of experts is a collection of expert models. For example, in the case of classification, many classifiers, smaller classifiers that are specialized on some subset of the population that are not predefined, and a router, a gate submodel that decides to which of these experts to assign every new instances at runtime. This is a solution, a very simple solution. It exists in the literature from many times. So for example, here you can see that this instance is assigned to expert 1, and so the decision is taken by expert 1. We extended this to a federated learning scenario. And major application of area of application are smart environments that we are trying to use to showcase and validate our techniques, clinical decision support, civil protection, and other ones. Cognitive building is an important topic for us. That was this research direction was started by our late colleague Spezzano, Gian Domenico, and a complex system, a cognitive building is a complex system. It's try to self-learn, to self-heal, and so on, and enabling technologies comprehend IoT networks, big data analytics, and AI, machine learning. And maybe it is important to put intelligence, artificial intelligence, to the edge. And this requires that AI algorithms and models are efficient, data efficient, and can run under stringent constraints, resource constraints. And we want to use, we want a process-aware cognitive capacity, okay, to understand what's happening, to predict what will happen. And this is a mix of three areas that are machine learning, but also knowledge representation for conformance checking and compliance checking, and control theory for taking optimal decisions. There are some case studies that have been developed by some colleagues of mine, by Antonio Guerrieri, activity recognition, indoor temperature. We have a lab in the institute, and there is a research line active in order to make these as efficient as possible. Another case, a human-centric sustainable AI for clinical decision support. The sparse MOE is the core methodological solution for enabling this kind of comprehensible. It is a very simple model, very lightweight. It is composed of linear expert logistic regression models. In this case, only 2 models have been discovered from a benchmark, a very simple data set, how this is. And we have 2 expert models that can be easily comprehended by clinicians, by healthcare staff, because they look very similar to risk score models that are very popular in medicine, and a gate model that maybe as a multi-output logistic regression is not so easy to interpret, but the approximated version as a tree is very easy to understand, and we can explain, we can extract in not approximate explanations, because our classifier is not a black box classifier, but it is a collection of linear classifier that can be interpreted faithfully. Okay, and this is I'm closing. This is the team at ICAR, at my institute. I am from Siena, and my colleague Pizzuti was the former co-PI of the task that has been replaced by Antonio Guerrieri, and these are the other ones, critical mass and other researchers, very active, them all. And I discovered a trend here, maybe with our machine learning tools, that it seems to occur a sort of long to short hair trend in the from left to right. And maybe it is not so reliable, and this is the team, the bigger team, because we have other collaboration within the institute with other groups. For example, Liliana Martirano, Carmela Comito, and Gianluigi Folino, and Massimo Guarascio, and Christian Cosentino, that has been at the stage with us, very interesting. Collaboration with Unical, collaboration with FBK in the team working at Spoke 2, and with the infrastructure. We are trying to establish some collaboration with the Tech for You. And ICAR is an institute that is inside the campus. It is in front of this building. It comprises smart lab, rooms, parking, and smart and kind people and bots. And I have to say one thing. During this project, I had the pleasure and the opportunity to work with many young people, very passionate, very committed, and looking forward to contributing to make the world greener, fairer, safer, starting from our region and country. And this we can do. My desire is to stimulate collaborations with these universities, with Calabrian universities, And I have to give a special thank to my young daughter that helped me elicit this dream, and also to put it into a graph, into a slide. And the final message is, let's make our best to capitalize Calabria and Italy's human resources and also next generation EU funds, maybe. Because I am a nostalgic guy, I grew up with the dream of Europe as a land of culture, wellness, freedom, but freedom with justice. And thank you.
Thank you. Thank you, Luigi. A lot of things, a lot of materials. I don't know if there is one question. No question, huh? So, Luigi, just one question about your very interesting presentation. So in many cases, you put together issues related to, obviously, energy consumption or energy-aware system and different layers of knowledge too. So how all this scenario may live together? So how you imagine that all these components would stay together in a general framework that is similar to the framework of the project in some way, no?
Yeah.
Thank you.
I said at the start that we pursued two different lines, but the two lines are very connected, interconnected one to the other, because we cannot spare energy now, use only quantization, distillation, specification, acceleration, without trying to reuse knowledge, if knowledge is available, and pre-trained models. But this is the natural trend now in the epoch of large language models. But we are trying to also try to do the best by using small models, maybe a collection of small models, language models that are not so powerful like the ones, and have to be combined. So the modularity and sparsity of models that is already used in large language model can be put at a higher level of abstraction, because we can use entire models that solve subtasks that can be combined. This is also a new trend in the so-called agentic workflow, combining different agents, but the data selection, data reduction, and sparsification, and also in training feature selection with gamble tricks or something like this are expedients, are mechanisms to spare energy and time. But the structure of the model is also important. The structure of the system, the AI system, is important.
Okay, thank you very much. Let's thank again Luigi. And the next speaker is Professor Carlo Morabito. Carlo is coming from Università Mediterranea di Reggio Calabria. So the title of the talk is Meta-Learning Approaches for Small-Size Clinical Data. Thank you very much.
Okay, thank you, Professor Talia, and I would like first to thank the colleagues of Unical for having had the opportunity to participate in this project through a cascade call, as it is said. And so Professor Carcello, Professor Talia, also Professor Pontieri, I'll present a specific, peculiar view of what is the subject, the main subject of our project. In particular, some, let's say, tailored way of treating data, in particular in the case of clinical data. The second part of the presentation will introduce the concept of meta-learning, and at the end of the presentation I will present some results regarding a specific application related to brain-computer interface in the case of motor imagery. My group includes Professor Iera Citano, Professor Nadia Mammone, and two other researchers working in Reggio Calabria, Domenico Rosaci and Massimo Merenda. And also we collaborate for these researches with two groups, one at Napier University of Edinburgh and at the Imperial College of London, Professor Hussain and Professor Mandic. This is I would like to say, Professor Pontieri, that I also remember Giochi Senza Frontiere. I think today is a bit difficult because students do not study geography. So it is difficult for them to associate the city and country, also in regions in Italy. An outline of my presentation, basically we look at the objective of the call, Green Deep Learning Approaches to Clinical AI. Our project is called NAEL, Novel Approaches to Energy-Reduced Deep Learning in Clinical AI. Mainly is related to work package 9.3 and task 9.3.3. And the objective is to design, development, and deployment of algorithms in clinical AI, favoring both the explainability on one side and the use of limited resources, particularly energy, but not only energy, on the other side. We use synthetic databases, augmented databases, augmented with standard techniques in AI, and clinical databases. I wish to say that regarding this point, as the project foresee a repository, we have to acquire some ethical consents from the hospitals in order to put the data, or I have to modify somehow this data, but we will discuss in other places. Basically, the idea is to incorporate signal processing to make informed machine learning, or at least partially data-driven, to introduce some explainability modules to reduce the impact of deep learning models, and the use of meta-learning strategies for reducing the need of data, because the additional problem with the clinical data is that we don't have at our disposal much data. So we have to work, it is clear, because data are classically unbalanced, because we gain more data from subjects which are considered healthy controls from patients with a specific disease. And we use at this moment both few shot learning and MAML that I will present. According to the activities we proposed in the period ending in March 2025, we have carried out the following actions. First of all, health data collection and pre-processing. We use, as I said, both online available databases and clinical databases. The former regards, for example, the application that I will show at the end of this presentation regarding motor imagery and Parkinson's disease, which have been carried particularly by Domenico Rosaci. The latter have been obtained through collaborations that we have for many years with the General Hospital of Reggio Calabria, in particular neurological data, electroencephalograms in specific disease, Creutzfeldt-Jakob disease, Alzheimer's disease, and psychotic epileptic seizures, non-epileptic seizures, and also imaging data that we received 1 month ago regarding rectal colon cancer. And again, there is a pending ethical committee approval. We carry out the pre-processing stages of this data to extract from them a collection of time, frequency, and time frequency features in addition to some non-linear parameters that can be used as features. I will show you some examples. This, of course, can reduce the computational burden of a full data-driven model and to comply with medical clinical interpretation. Just a very quick example. It is well known that in Alzheimer's disease, the EEG shows a characteristic effect which is called slowing. Let's say the frequency of the electroencephalogram is relentless and goes towards low frequency. So the power content of different bands changes. Of course, if we give the full data to an AI model, the AI model can learn this thing. But of course, we can reduce the computational burden of the model if we somehow introduce this a priori information. So we developed the novel algorithms that are energy aware, and also we extract some appropriate learned feature maps on the not full data-driven model, and looking at one thing that has been said before, not reducing the performance in terms of accuracy or some other metrics, particularly in the case of reduced cardinality of the available database, as it is in our case. The WP4 regards the explainability and interpretability in the sub-case of green AI. And finally, the deployment of on-edge AI, which is carried out by my colleague Miranda, in order to have hardware models. So, some example. Here, we have the EEG recordings. The EEG is a very complex signal because a multivariate time series signal, which is collected in specific points on the scalp of the subjects. And there are not only, of course, we have a strong time resolution in the order of milliseconds, but the spatial resolution is not so good. So it is possible to introduce more electrodes, so having the so-called high density EEG and so on. Anyway, this is the signal that you can have. Then here in this example, I have a transformation, a 2D transformation in time frequency, and then compute a sort of map which is represents the complex network underlying the model, classical adjacency matrix in which the edges of the graphs are represented by cross correlations, or in this case wavelet coherency. So this is the help of transforming time signals in time frequency. But it is possible also to have additional information if we consider in the bottom row not only the time frequency analysis, but also the a non-linear analysis, which is basically the recurrence plot that links somehow the samples of the EEG in different times. Again, it is possible to reduce the great amount of data. You can see here 2 channels Here we have 19 channels, 2 channels transformed in time frequency maps, and then extract some features from the averaged time frequency maps, for example, mean, standard deviations, kurtosis, and other statistical parameters that generate the embedding vector that can be reduced again through a stacked autoencoders for making a simpler classification, for example, in this case, healthy control from psychotic non-epileptic seizures. This has been carried out with the colleague in Edinburgh. We use not only the time frequency representation, but also the 2D big spectrum or 3D big spectrum, which is a sort of representation of the correlation between different frequencies of the signal. But you can see here clearly that above, on top, we have the representation in the case of Alzheimer's disease patients, in the center, mild cognitive impaired, and below, healthy controls. It is clear from these exacerbated cases that there are some figures in the time frequency representations that are characteristics of AD, are elliptic forms that cover at the same time more frequencies. This is the pipeline of the approach using both time frequencies analysis and bispectrum analysis. As you can see, we have 2 channels, one for only CWT, continuous wavelength transform features vector, only bispectrum feature vectors, or multimodal feature vectors. In this case, we have more binary and ternary classifications in the case of Alzheimer's disease. Another way of reducing information is through some non-linear parameter. For example, the entropy. You can see here an example that shows that the entropy can be reduced through some autoencoders. And it is clear that, of course, we lose information. But at the last stage, when we have lost information, the 2 classes are more separable. So in this case, reducing data implies better classification accuracy. The meta-learning, it is basically a learning-to-learn strategy that we use in our clinical applications when we have a scarcity of available data, data imbalanced, domain adaptation, for example, intersubject and intrasubject variability, because the EEG is very different from one subject from another subject. So it is difficult to adapt data and so on. Okay, the usefulness of meta-learning approaches in addressing this specific problem, intersubject variability, it has been shown in some experiments we have carried out. In particular, I go ahead. The effectiveness of this framework has been analyzed across various data sets and backbone networks. We use basically the DeepConvNet as baseline, and so we measure the difference with respect not only in terms of accuracy but also in other metrics that are proper of this project. One meta-learning approach that we use is the so-called model agnostic meta-learning, in which basically we use different tasks to build a suitable trajectory of the weight correction. And this gives us a representation optimized of the weights that allows to quickly adapt to new tasks. We have at this moment no specific results for the model agnostic meta-learning algorithm, but we are working on this. In particular, to address the training phase with diverse non-subject and adapts to unknown subject. This is a short pictorial representation of the difference between multitask learning and meta-learning. In meta-learning, we use the tasks in order to learn how to learn, and then quickly learn a new task. For example, in this case, the decision regarding this is a simple example. I will show you a more complex examples. The child decide what is this animal by knowing some examples, and in the case of few-shot learning, we have in this representation just 2 sets of cards and 4 classes. We say K, way, and shot support set. Basically, the similarity function is extracted from a previously trained large-scale database, and then we use the support set, the query, so-called the query, in order to decide through a similarity function which is the animal that is nearest to the query. This is the sort of mathematical formulation. Basically, we have a set of parameters that are solve a specific task, and an outer procedure that improves the parameters. Just the examples that I discussed. Very quickly, we have a problem of motor imagery, and we have as a first domain 5 tasks that regards the movement of a right arm, elbow movement, rotation of the hand, or resting state. So we learn on these 5 tasks, and then we use as target domain 2 different tasks, basically unclosed and unopened. The aim is to train to classify the samples of the source domain and then adapt the pre-trained model for the recognition of new tasks and close and open. This is a description of the dataset which is made available online, so we can of course introduce in the repository. And motion data to be associated to the EEG is given by a glove that is equipped with sensors for the movement, the motion sensors. This is the procedure we use. Basically, the subject is as a cue that is arriving the specific case, and I wish to say that we use motor intention. Let's say we use a set of EEG data indicated in blue that are before the movements. So we make a sort of anticipation of the movements by the EEG signals. Then through time frequency analysis, filtering, and so on, we gain channels by frequency, by time maps stratification that can address the learning problem, which is for the source domain, and then in the second part, in the bottom part, the support the query for the other 2 typologies of movements. Just the results, you can see we have 14 subjects, and you can see that, for example, the 14 subject has no good results, are under chance, but remember that it is made not during the movement, but before the movement. So it is a motor imagination problem. Indeed, we have used different metrics, in particular the average K-Cohen correlating the results achieved and the known result, let's say, as we use for comparing with the true result. And so we, just to give a number, we had 72% of accuracy and 80% accuracy in the target domain. Please take into account that we have normally numbers like 50, 60% of accuracy. So there are good results by using these meta-learning strategies. So in conclusion, we are working for different developments regarding green AI models and to deployment on the edge of ML. And also we are considering 2 workshops at the Italian workshop on neural networks in June and at the IJCNN in July, 2 special sections regarding fair application. So thanks a lot for your attention.
Thank you, Professor Morabito. You presented very interesting research work, so we have not so much time, so sorry if we will not provide you with some questions, but we have opportunity to discuss all that. Thank you very much. So the last speech is from Professor Mario Cannataro from Magna University at Catanzaro. So the title of the talk is Green Aware Approaches for Artificial Intelligence, Bioinformatics and Text Mining. Please, Mario.
Thank you, Mimmo. Good afternoon. First of all, I want to thank Professor Talia for introducing me and the organizers of the workshop, Professor Scarcello and Professor Guzzo. Before starting, just a few words about my university. University of Catanzaro started the program in computer engineering and biomedical engineering in 2001 inside the Faculty of Medicine. So we are working on bioinformatics and medical informatics since then. The goal of this presentation is to introduce the first preliminary result of our project, our participation in this project. We won a cascade call, like Professor Morabito said before. In particular, so I will explain our role in the project and the 2 main pillars of our contribution that are green AI bioinformatics, the design of some software in bioinformatics that are also green, and green aware text mining, because text mining in particular, but also sentiment analysis, are more and more used in analyzing clinical documents and, for example, patient review. And so I will conclude with some first result and future work. Okay, in this slide, I will summarize what are our goal. In particular, we are experts on bioinformatics and text mining applied to clinical documents. So the idea is to port this contribution in a green aware way. Regarding the bioinformatics, there are several, of course, algorithms in sequence analysis, for example, protein structure analysis. We concentrate especially on network analysis. Network alignment is a typical activity that is performed for comparing, for example, the protein-to-protein interaction networks of several organisms, but they are used now for comparing, for example, the brain connectome of patient that is extracted by functional or structural magnetic resonance imaging. On the other way, another field of research is text mining, in particular, or sentiment analysis, for example, polarity detection, that is especially used in marketing, for example, to check, to write a review, textual review, but now it's also start to be used in medicine, for example, to compare the review of patient about medical doctors or health centers, and to extract knowledge from textual document, for example, from the literature that is available usually in a textual format, and also in other fields. For example, to extract knowledge from operational clinical documents that are made by medical doctors. For example, the clinical reports when they take an examination of the patient, or for example, during surgery, medical surgery, people has to write a report on what happened during the surgery operation. And so, for example, from this document, it's possible using topic modeling or name identity recognition could be useful. These techniques are useful to extract knowledge, for example, about the stress, the burnout of health personnel, and so on. So this just to give an overview. What are the main direction that we are using, we will use to improve the energy efficiency of this algorithm? Of course, the use of distributed computing, in particular edge-based computing. For some activity, we also used serverless computing, cloud computing, but in a serverless way. And regarding instead, so the idea of edge computing, as said also before, is to move the large part of computation where data are produced. For example, close to near inside the hospital where DICOM images are produced. And regarding text mining, instead, our approach is more oriented to avoid, if we can, to use machine learning, and in such a way to integrate not machine learning based approach that are very efficient but are not very precise, not very accuracy, with machine learning based methods that on the other side are often not efficient and not explainable, as also explained in other relations. So in particular, we made some experiments, some preliminary experiments, that this, for example, measure the consumption of power in different components. We made a classification of MRI data and with graph attention network. And in particular, we tested several configuration. The Intel configuration is the worst with respect to the consumption of power, while the NVIDIA Jetson is quite good, because other configuration consume less power, but for a long time during the training of a machine learning algorithm. In this other experiment, instead, we used a different approach. We used the distribution of load on a serverless computing environment. Here, we developed a very simple infrastructure where they applied to the alignment of RNA-seq sequences. RNA-seq is a format that is used in next generation sequences to map the genome of an organism, of the human, for example. In this case, we have a problem of big data, a problem of a lot of small read that have to be aligned to obtain the entire genome. So here the idea was to apply a combination of parallel computing to distribute the load and to use not real server in-house, but using the computing power offered by the Lambda paradigm in Amazon serverless computing. And so this could be a different approach in solving some kind of problems where the data is originally deployed in just one point in the next generation sequencing machine, as there is the space to distribute it. Concluding this first part of our contribution about the bioinformatics, the future, the key points are the use of parallelism and edge computing. In particular, we are testing the NVIDIA Jetson system, And as a result, we plan to develop an energy-aware pipeline for classification of fMRI magnetic resonance imaging. Here, the processing of this data require a lot of several tools. For example, fMRI prep for pre-processing the DICOM images. Each DICOM is about several gigabytes of data. Then to extract the connection, the brain connectome of this brain fMRI data, we use the CON toolbooks, and this will be made locally where the data are produced. On the other side, the classification based on graph attention network, if you use a machine learning model, or just the comparison of the network of several patients using network alignment will be performed in a separate central node. For example, here we made some experiment using public available data from OpenNeuro. Here we got some MRI data from depressed and not depressed people, and we demonstrated that there is a degradation of the network structure of the brain of these people in the depression patient. Regarding instead the other field, so I'm going to in very speed way, because I know that we are at the end. First of all, we analyzed some methodological approaches for improving text mining and polarity detection. So first, for example, the use of both non-machine learning based and machine learning based system, and of course the use of hardware that can accelerate the process, for example FPGA, and the use of also of system, for example LLM for making some specific question. After this brief state of the art, our contribution, which is the planned contribution. For polarity detection, there are two main approaches. The lexicon-based approach, in which the polarity detection is based on the basis of a lexicon that is provided for a specific language. For example, in the English language, we have a very common system, is VADER, and it uses SentiWordNet as a lexicon, and it employs just very easy rules, few rules. So it is a rule-based system in which there is no a training phase, because the training in such a way is inside the SentiWordNet lexicon that has been labeled in the past. As a first contribution, we developed an Italian version of this tool, Vaderit, in which we just adapted the last three rules. But one problem of this approach is the fact that the tool is very good to recognize positive polarity sentences, but is less good in negative polarity. So we are working both on improving the negation detection and on trying to combine machine learning based system with this system. So, for example, a first approach will be to use VADER only with a set of sentences that we are aware that the efficiency is good, and so to do the polarity detection with machine learning only for more complex sentences, for example, where there is the irony or where there is a negation. And other things other approach will be to use this system to improve other text mining approaches, such as name entity recognition of topic modeling. So in this way, we have the first version of Vaderit. We are improving the negation detection part. As conclusion, some of these preliminary results were disseminated in some conferences, in particular the IEEE by IBM conference that was held in Lisbon last year. And as said before, the rest of activity until the end of this project in November will be the implementation and testing of the fMRA-based classification system and the extension of VADER toward an hybrid model in which we use a rule-based approach for a class of sentences or a class of text to classify and machine learning approach for the other. Of course, thanks to the group, bioinformatics group, that is composed from the following faculties and PhD. Thank you.
Thank you to Professor Mario Cannataro, and we are going to close this session. I say just a very few words to thank all the speakers of the session and also to consider that the contribution of University of Reggio Calabria and Catanzaro are perfectly aligned with the goal of the work package. So I'm very happy of what I heard today, and I'm sure that your contribution will be very important for our work package and in general for the project. So thank you again. Please, Francesco, I don't know if you want to close the session. Otherwise,
just to thank you all for being so precise, and thank you all for the participation, and see you later for you will join us in the dinner, and otherwise for the other tomorrow morning here. Bye, goodbye.
Good.